engine. Any questions so far?
So when you refer to JSRT,
yep.
Is that the Chakra API?
Yes, that's the Chakra API, yes.
And it's in C?
That's in C, yes. Okay.
That's the flat C API used to embed Chakra.
Mm-hmm.
Is that the same that the browsers use? Or?
No, that's different from the browser.
Yep.
But that API is the same that is used by some of the other hosts that we were talking to. For example, the Microsoft Azure DocDB service, which is a NoSQL database essentially, uses this API to host Chakra. There's Outlook.com, which uses Chakra for server-side templates and stuff. They use this API. There was Cortana who was using this API.
It basically is part of the Windows SDK, so it's available on all Windows platforms. So that kind of explain a brief touch on a brief history on the why, and so basically we collate a list of all the the DLL imports that the node with Chakra uses, and we categorize them in terms of kind of the different capability or the what they're actually doing. So that probably gives you an idea of actually what node is needed in terms of granular engine capability and what kind of interaction you need. The first set of API is kind of basic, like bootstrapping, just creating the runtime and then do garbage collection, handling exceptions, and allow you to implement like promise task queues. And then the second set is kind of similar to good context management. Basically, it's it's same as V8 context. So you use that to create the initial context and also implement the VM contexts. So allow you to create and set the current context on the. We have a TLS as well to manage context, and also allow you to associate certain external data to a certain context, and ability to get the global object. The first set is basically kind of a object lifetime management. So it's kind of similar to V8's local and persistent handles and those classes. So you have add rep release basically takes strong reference to those objects, and just set object before collect callback is basically resurrection. So that's kind of the so these three sections are basically kind of the more global, more like directly engine object manipulation. The next set is more.
Actually, could we stop here?
Yep.
So are there questions around these three sections? We can. Okay. Keep going.
So the next sections are basically just kind of implementing JavaScript semantics, where you. Is a lot of the operations you can actually write it in JavaScript itself. For example, equal and strict equal is directly mapping to what JavaScript specifies as equal and strict equal, and allow you to actually get the singleton value like undefined, null, and true and false. Create objects, a whole bunch of kind of objects that you can create arrays, functions, objects, symbols. Some of the JavaScript object type is not directly exposed in the JSRT APIs currently. For example, you can't create a proxy object using the C API itself. But in Node, if such requirements is needed, we inject a script when you initialize the context, and we just get the built-in proxy constructor, so that you can use it later on. But those are directly mapping to JavaScript semantics, and that's why that can work too.
I don't see specifically the unit data array, only because that's basically the implementation detail of buffer.
Let's see.
Conversion.
I don't think that you actually create a type array per se. You always create an external array buffer.
Used to, then they changed it, so now we have to use. We used to use an API that allowed us to attach external memory to an object,
Yeah.
any arbitrary object. But then they removed that API, and now we need to use the type array implementation.
Right, right. So that's the JS create external array buffer. Array buffer is the underlying data
Yeah.
for type arrays. So you can overlay, like basically you can give an array buffer to any type array, and basically it will just use that buffer as the that's the view. So so that's the API that you would give the your buffer to, and it will create the array buffer, and you can use it as type array.
Okay.
So when you say you don't expose all the types, I'm just thinking of like modules. Are there any cases where the modules would write something that works with V8 but then doesn't? Those things haven't been exposed, or is it that the wrappers you have with all these take care of all that?
Right. So the wrapper that we've written have taken care of those. So basically, the strategy is that most of those types are basically JavaScript built-ins, like maps, if there's a need, like map, set, weak maps, proxy, those kind of JavaScript objects. They have equivalent JavaScript constructor for those that is on the global object. So when you initialize your global object, we can just take those built-in out and then call them as if it is just a JavaScript function, and then you'll get those back. So that kind of removes the need to add new JSRT API for every single JavaScript types.
So instead of doing things on the native side, you just call these.
Yes. Yeah. Of course, there's always option to add those APIs, but at the time we didn't. So.
Right. So I guess like you haven't found that performance-wise.
Right. Right. So object creation and value coercion, basically just converting values to from native to JavaScript and JavaScript to native, or between JavaScripts. Calling that like to primitive and stuff, and to object, to string.
And what's the pointer string or string?
So basically a string buffer to JavaScript string.
Oh.
So if you're going to V8 quote-unquote string from something.
Do you what type of string coding do you use, by the way? Is it all like UTF-16?
Currently, yes. Yes.
So you like in the shim you just convert UTF-8 to UTF-16?
Right.
Okay.
Mm-hmm.
Did you find any performance issue with that?
Probably. Right now, our performance is not as good as we want to be, but we are working on that.
Okay.
I mean, I don't know
V8.
Yeah, I don't know like internally what V8 has internally what their string representations are, but our internal implementation is actually UTF-16, and we do all our operation, most of our operation in UTF-16.
Yeah, so the V8 is like either Latin 1 or UCS2 technically.
Yeah.
You also use.
It's either 2-byte or Latin 1.
Okay.
Which happens to be what Red Hat uses.
Okay. So I mean, converting to from UTF-8 to Unicode usually is not as expensive in terms, and since our natively we want to use it as UTF-16 anyways.
Right. Wait, sorry.
Mhm.
I assume you have binary coding, right? Because buffering your two-string binary.
Pardon me?
Okay, so say you have to take a buffer and you say two-string, and then you say binary, right? That's the binary encoding. You know what I'm talking about?
Binary encoding.
There isn't really such a thing as binary encoding.
No, it's technically like it's ISO 88591-1, technically. But for some reason, well, way back in the day before, when the V8 only supported ASCII, it didn't support a 1-byte API. It was called binary for heaven knows what reason. I think it was for crypto at that point. But then V8 moved over to 1-byte, which is the Latin one. And for legacy reasons, we just continue to call it binary. But you.
Well, so the thing, so I think what it comes down to, and there was also an issue in Node at the time, is, you know, if you want to map, like, you know, every byte to a, you know, a character essentially, then the internal, you know, the representation in memory, like every byte uses up 2 bytes, right? Because they use like a 2-byte representation, and like every value becomes 1 character, and so,
Yes.
which is not very efficient, of course, from memory perspective, but also performance-wise, like taking a binary thing and like making it twice as long actually is like a, you know, a fairly involved
No, I'm talking
operation.
about the string and pointer. I figured that, or sorry, pointer and string. That's like saying take this buffer and turn it into an internal representation. I assume
Yes, but it assumes, that's what I just asked.
Yep.
It assumes that the buffer is UCS2, so like every 2 bytes represent 1 character.
So you can't say UTF-8 or binary or hex or like
Currently it assumes that you can use whatever buffer it is, but internally we will just interpret it as a 2-byte string.
You want UTF-2 or UTF-16?
UTF-16.
Assume you mean UTF-16, not UTF-16.
Well, JavaScript doesn't support, I mean, it has
Okay.
no concept of it, right? Like it treats a string as an array of 16-bit values, which is essentially UCS2. Like you can have, for example, half you know, like a match surrogates in your string. That's fine. JavaScript doesn't care. It's only like when you actually try to convert to UTF-8 that becomes an issue. But I mean, that's an issue with the browser as well. It's not really unique to Node.
Well, the ESXspec does allowed for surrogate pairs.
There's now operations that refer to it as.
I mean, yeah, in regex you mean like but that's I think ES7, right?
So it strings to their API to actually interpret a string in terms of copoints.
I don't think I think that's not true. There's nothing in the standard so far that says we are going to.
Anyways.
Okay, we're getting on.
Yeah.
You're right. Sorry.
So basically, you can pass it whatever buffer you want, as long as, but we'll just interpret that buffer as in 2-byte strings.
Okay, so I can't tell you it's UTF-8 string.
Well, the shim will convert it using
gotcha.
yes.
Okay.
We implement the conversion in the shim itself.
Gotcha.
So these are the actual direct interaction to our engine.
But we also convert.
Yeah. As soon as your user API is like, I just pass like, oh, it's this,
Yep.
this or this or this, right? But you know.
Right.
Yeah.
And then there's some the JS value manipulation is a little about grab back of stuff. So JS instance of is basically a JavaScript operation equivalent, get prototype and set prototype as well.
Okay, so the string length. So V8 has I assume that returns it's basically like the byte length divided by 2, right? Because
not byte length, 2-byte length. So it's actually the actual number of characters.
Yeah, exactly. Well,
Yep.
what I'm saying is, it'd be the 2-byte length or
Yep.
the byte length divided by 2.
Sure.
Right. So that's because internally it's represented as in the shim. Okay, in the shim, you also have the conversion to get the UTF-8 length.
Yes. If there's a API call to get UTF-8 length, I'm sure it would convert it. Yes.
Yes, of course.
I did not write that part of the code, but I assume so. And you can get information about array buffer so that you can get back your native buffer from a type array. The JSRT property ID is probably specific to our engine. We represent basically property name as IDs so that you can actually intern them and cache them instead of asking for like for every single time and convert it into a record. So that's more in our internal implementation. But we use those to to implement the next set of to use in the next set of APIs which do property access. So define, get, set, pass. So those are basically mostly just translate from the ESX spec of what a JavaScript basic JavaScript operations are. And the last set are basically like what you need to run the code. Just parse code, run it, and construct an object. And the last one is to do a native interrupt so that you can hang native data or whatever data you want in a JavaScript object itself. It's kind of like an internal slot for an object or just associate data.
Is it multiple slots or one per object, or how does it work?
I think it's one per object. So you can create I think in the shim, I think the API allow multiple slots, and we just implement it as like I create an array for it. I think in Node we only use maximum of 4, so we always create 4.
Okay. Well, I think in Jade you have to declare upfront how many slots you need, right?
Yeah. So that's basically it for what Node uses the API for. To drill into some of the APIs that are interesting, basically the APIs that we actually add for various reasons, either for functional.
Just one quick question of that list.
Yep.
Is that, like, what percentage of the existing API that you had is that like, cover most of it, or most?
Let's see. Sorry. Incursion. I think we have that at the end, right?
Yeah, but I mean, it was a small thing. And, I think it was about 75,000.
So these are the set of APIs that didn't get used, but we exposed it. Some of them might just be that we didn't actually implement it in V8 because we didn't have them find a use in Node or a unit test that fails, or native modules. So this set of API, I'm not claiming that this is all the APIs that is needed, but implementing those have given us like getting most of the unit tests running, except for like debugging and some of the internalization APIs or error message that fails because of error message differences. And we have gotten quite a bit of native module running as well. So it does give us a sense of, maybe 80 to 90% of what core Node would need. And the majority of the native module would need in terms of what it needs from the script engine.
I have one question. I don't, or maybe you're going to cover that anyway. But what does, like in this sort of native Chakra or JSRT API, what does a C function that can get called from JavaScript look like? So so the V8 equivalent is like currently, I think, void, and it gets like const arguments passed by reference or something.
Function template info.
Function template, yeah, exactly, like that stuff. What does it look like for Chakra?
So for Chakra, we just pass you the actual pointers to the JavaScript object itself, and you can basically we call it just bars.
So you get like I specify a function in C, and it takes multiple JS var arguments, or
right. So basically, it has a signature of like you have a var return, which is it's kind of like a JavaScript function. So it will have the first argument is the function itself, and the number of arguments, and then just a var of arguments. Right. And then you can interpret those and use the JSRT API to ask like what it actually is. Is it an int? Is it a double? Is it a string? And then you actually get the native buffer from it. And then call your C++ implementation.
And so how do you get access to like the stuff like the dis object? And in V8, I think you have something like a holder, which is sort of the dis, what this should have been.
The holders, yeah.
So we don't have a concept of handles or basically wrapper for the internals. We just give you whatever internal pointer we have.
No. I mean, so what I mean is like, I'm in C. I'm in my C function that got called from JavaScript. How do I get access to the dis?
Oh, the receiver.
The receiver, yes.
It's just the first one.
It's always. Oh,
okay. This. Okay. Sorry.
It's always there.
Yeah, it's always there.
And how do you ship? So how do you shim holder? Right? If you have no such one. So.
You can probably just walk up the prototype chain and search for it. I mean, that's what we do.
Say that a little louder.
You walk up the prototype chain of the dis object.
Yeah.
But I thought the holder was like, if you. Okay, maybe I don't understand. I thought like you can always pass anything for this essentially, like with function prototype.
Oh yeah, that's true. I mean, like if you construct a call, but if you have the real object and invoke some getter for the property, but the property is like the getter is defined on one of the prototypes.
Right. Okay.
Get it. Like
Holder is the prototype. Does holder refer to the prototype?
I don't think holder is a prototype.
Okay.
And I think
confused with that too. So
I think holder is like if you define a JavaScript callable function in C and you stick it in an object, then the holder is always the object that you stuck it on, regardless of the value of this. You don't get there by walking the prototype chain. You just need to keep that. Yeah. You need to track that somehow.
All I know is that we started using holder in core to prevent people from doing like prototype.call, like the function.call.
Okay. Why don't you use signatures for that?
And then it crashes because it doesn't have like an internal field that the internals expect. So the holder is kind of the safe version of this, from my perspective.
Okay.
From our perspective.
So what you described sounds like you should use a signature for it.
Should use the.
Like, so if you install something somewhere, you can put a signature that says like this can only be invoked on things that were constructed from a certain function template.
Okay. I don't think we do that. Oh, but so I was just curious how you guys sort of emulate it or whatever.
I don't have it
Okay.
in my
and how do you
brain
do
right
that?
now. It's in code. Yeah, I don't know right now.
All right.
So
that's in the Chakra shim code, right?
Yeah, it's all in the Chakra shim code. So I just want to drill into or bring out a set of APIs that are explicitly added to our API set, so that for multiple reasons, mostly for one for functionality, where node needs it and there's no other way around it. The other one is basically for performance reasons. That doing it, we can definitely write it some other way of using more the atomic APIs or different kind of APIs, but because the multiple round shipping kind of makes it a little bit more expensive. So, for example, JS instance of is a JavaScript operations that we should have exposed already, so we added it. So it's the type array info. So the context, associated context data we have to add before. We don't have that concept previously, and Node definitely uses it, so we added that. Create external array buffer. Originally we didn't need to. We don't have a case where a type array is provided by external user. IE always asks us to create a type array and give them the buffer, and they'll just populate it. So this is a new capability that we added. Enable experimental features are basically Node does make use of some advanced ESX features that originally we did implement it, but it is not in the it's not enabled by default. So we have to that switch so that we will switch it on for Node. I forgot what generators, I think, is the case here that we added this for.
But I don't think Node uses generators.
It does. In the REPL.
Trevor, because he would know. Oh, in the REPL.
Yep.
Yeah, it does.
Yeah, like one case.
Yeah.
One case.
And then the last three is just or just numbers to int, and let's see, is for perf. There's converting a number to an int is a very frequent operation.
Now, is that a 32 or 64-bit?
32.
Huh?
32.
Okay.
I mean, that's the same as Java, as V8.
No. 2 integer gives you an int64.
Oh.
Yep, so that you can reach the full 2 to the 53 integer values double compressed.
Okay, yeah, that's.
That's more.
But I mean, you could shim that by simply getting the double value and passing to it.
Yep. And we already have API to get the doubles.
Yeah, and this is more of a perf optimization, right? I mean,
Okay.
we can have it represented as a boxed number.
Mm-hmm. And last but not least, we added the API to resurrect objects.
Yes. Which we've just been told is being removed.
And for the record, I don't like it either.
So in what cases is it in Node do objects get resurrect?
I know it's at least in VM.
So I've removed them. Basically, and actually that fixed a big memory leak that had been there for a long time. So.
And if it's like I pointed out earlier, if it's really the performance thing that you need, the object, you just should clone it.
I mean,
Yeah.
when I wrote this function originally,
I'm actually looking at that right now.
So that's basically the API sets. Any questions?
Is there a walkthrough of the shim as well, the code that we should briefly do, or do you think that's too detailed?
Yeah, that's a little
to understand. So going through what your native API is now, how did you actually have to map it for 450? What does that look like? And if it's too much detail, and we can.
Yeah, maybe just.
Let me. I'll bring up a couple of files from the repo. And
just one example.
Yep.
Sorry.
I'm curious, like the wrappers seem to, this seems to be the minimal API that goes to the VM. Is there stuff in the wrappers that you would, could we ask end users to call that API who are writing their native modules? And would that be enough? Or is there a bunch of stuff done in the wrappers for V8 which you'd want to provide in addition? So really it's twice that number of functions you want to implement.
So I think that one of the, I think back to Johan's point is that a lot of the, some of the shim that we implement are basically for a little bit more high-level abstractions, where, for example, function template, object templates, you give it a set of fields, and then it will just generate multiple objects of the same type, same kind of shape for you. And our API definitely does not have that. So we actually have to build on top of the atomic API to do that. I guess one other way is you can use the shim to call the JSRT API, and then you'll get what you want as well.
So, but to your question though, right? I think from a shim perspective, what the shim does is it actually, if you kind of think about it as a layer, right, and Node sits here, or so to say, Chakra sits here and Node sits on top. The shim actually makes the APIs look just like the V8 APIs on the top, but is internally calling these JSRT APIs.
Right, I'm just trying to...
And there's a mapping that all happens inside that shim.
Right, I was just trying to understand, is there value in that shim layer beyond making it look like V8 to the end user? Right, like...
To the end user, yes.
Right, like you can, that it makes things a lot easier to do, because it's got like these things which are...
So help me define like who when you say end user.
I'm running my own native module.
Gotcha.
And, you know, I could do that with these two APIs. I can do it writing it to the V8 API, or I could do it writing it directly to this lower level API.
Mm-hmm.
Is one going to be easier than the other? Like, is that shim making it my life easier in addition to making it look like it?
So, I mean, I guess that's a matter of taste or preference to a certain extent. But from my perspective, the V8 API is a little bit more like convenient because it, like, I'm thinking of examples. Like, for example, most of the time you don't actually have to explicitly root variables and unroot them because handle scope takes care of that. That means, objects just have like a .get method and you pass it a string and it will give you the value back. So like there's certainly a certain level of convenience that comes from the C++ wrapper. I think.
So even if you had a C API, it might be useful to have a C++ wrapper, which then does a bunch of that.
Yeah, I mean, and you can imagine that, like, if it's not too hard, that there could be multiple C++ wrappers as long as you compile that part into your module. It's fine. So, like, NaN could essentially, I think it's imaginable that you say, well, we're gonna, add, Chakra support to NaN, for example, or like C.
Right. So I can, could have multiple people write different ones if they think they're.
Yeah, exactly.
You get separation at one level, but then you have this convenience layer and C on the top.
Yeah, exactly.
Okay.
So, has anybody done this work for SpiderMonkey or any of the other? I'd just be curious to compare another one.
They have a very long time ago.
Long time ago.
It was never the prototype kind of worked, something around that area. So like around 2012.
Did they do any kind of analysis like this, comparing the API structures?
Like I haven't, but I mean the approach was similar. So they also shimmed, they implemented the V8 API using SpiderMonkey primitives, but they didn't get as far. So I don't think it was like fully featured or whatever. And what was the project was called? SpiderNode. Yes.
SpiderNode. And it never made it out of lab, like gone out of lab.
Exactly. I mean, I think it's also like there was a little bit of like organizational issue. Like what Mozilla did at the time is essentially had like a couple summer interns write that thing up, and so by the time they left, it was pretty much an unlinked project.
And there, there's JX4 also, and that's kind of a questionable state right now too. But JX4 went through and implemented changes to get the work on SpiderMonkey also, but that was 0.8, 0.10 when they did that, and they were never able to actually keep it up to date. So.
So I think the challenge isn't necessarily in like writing a wrapper. It seems with sufficient effort we can do that. It's more like, setting up our organization, if you will, so that it's not impossible to keep up to date. Or like we would not ideally not make a change that made it impossible, or like or the abstraction would have to change otherwise.
So this is the file that implements V8 objects. So a lot of the functionality is very similar to, it's basically a direct translation. For example, if you set a property with index, we just call set index property, and all of the V8 object types are basically pointer to our own internal objects. We just shim it that way, and all the basically method on those objects are operating on our pointers, and that would be this pointer.
So is the final property a set, for example, is that actually semantic preserving?
Pardon me?
Like in the API set, basically, if it finds the property on the prototype chain, set it there. That might be that it has the property with a setter, whereas the final property always defines it on the current object.
Right.
And so like here it looks like you're translating the final property to a set, which would be
with
different
force.
semantics. Well, what does force mean?
Force means always. So it just set it.
Okay, and what is if the property was non-configurable, non-writable? Details.
Yes, details.
So I mean, but it might be that Node just doesn't rely on these exact semantics, and so that's why it works. Right? Like it sounds like.
So a lot of it is just either directly calls the JSRT API, or we have little util functions to kind of make it easier. So for example, this one is get property attributes. So basically, we just get the property and get a whole bunch of attributes of whether it's enumerable, configurable, or writable, and then translate it into the attribute sets that V8's passed out. So a lot of it is basically translation from our JSRT API's output to V8's output. To the other extreme,
Are you volunteering to come on?
pardon me?
There was a comment from the viewers. It sounds like it's not very hard to maintain.
Right.
Well, I mean,
not
very big
yeah, I mean, if the API shape does not change, yes, it's totally easy.
well, I mean, to me, actually, it's kind of the opposite. Like, the fact that we look at it for like 15 minutes, I don't know, and we already find a case where the semantics are not the same. It kind of like makes it sound it's actually hard.
Right.
Well, yeah, and I think it goes back to back to the point that we really have no real clear understanding of this is the behavior that Node depends on, right? It's, you know, I think it's just by accident that this happens to work. Right? Testing verification. If V8 was to change, you know, the semantics, you know, in the internal semantics in the beginning, some fairly subtle ways, this ends up breaking, but we wouldn't end up having the.
Hello, everyone. Sorry for being late.
Exactly, breaking is what makes it much more difficult to actually maintain.
So, okay, just, you know, something as innocuous as you did mention earlier, the not too wide a line pointer. Like, what if that had, well, something similar where it would run track properly, go V8 for whatever reason, whereas, yeah, I hated that problem.
So I mean, what I was also talking about earlier, one thing we do in Chrome is that we try to separate our stuff that is like purely spec compliant objects, so like all the web APIs we expose, and then we try to have a directory where we basically keep all the V8 specific stuff and have C++ wrappers for all the JavaScript types. So like the rest of Chrome never gets to deal with a V8 promise, but they always get what we call a script promise, a C++ class that does internally the dispatching to V8 back and forth. And I would expect that like all the wrapping that more or less exposes C++ APIs to JavaScript is supposed to be more or less is supposed to be completely standard compliant in the sense of like that the objects it creates and the behavior it exposes is what you would expect from any other ECMAScript object. And so currently when I look at Node.js, this is to a certain extent intermingled with like non-standard stuff or very V8-dependent stuff. And so I guess the first step in like any direction, like even if you don't do the neutrality, but just to make code more maintainable, to separate these things out. And ideally, that the binding of objects that are like no way special. It's just like a C++ API or like whatever, C API or whatever, and you want to expose it to JavaScript, could even be auto-generated. And like auto-generation in that case might not be something you want to give to native module authors, because that wouldn't give you the properties of like having a stable ABI, but it would still give you the property that there's like a single, like the generator for the bindings that you have to update and maintain or replace if you want to replace it. And that kind of should be straightforward, because it's like it talks about how a C++ API would map to an ECMAScript object model. And yeah, and would separate out the code that is different per VM.
Yeah, and you just need to convince everybody what that stable is.
But like, I mean, so this will necessarily be. I mean, the thing that would be stable is kind of the IDL, right? The compiler and the VM-specific stuff can change every commit. In addition, we still need a stable API stable API we can give to native module authors. And these ideally wouldn't talk to the VM at all. Like anything from the VM we want to expose to a native module should go through an defined API.
So basically what you're suggesting is, or maybe I'm getting this wrong, but V8 will just have a super unstable API, and we carry our own shim, essentially a node that we expose to module authors. Is that kind of what?
Well, so I mean, I think there are two things, right? Like if you talk about module authors, then we should. I mean, we kind of said earlier we should have an API that just doesn't change, at least on the major release, and like not an API, but really an API, right? And so I think it makes sense to put that into Node Core, so you have full control over it. And I think it should talk about more than just the objects. Like if you want to post something on a microtask queue, Node should provide a standardized, stable API for doing that. But because otherwise you will have to recompile for these things.
Yeah.
Right. And then the second issue is like, can we move Node.js itself closer to a model where we could talk about how can we do anything with it without forcing at least one of the engines to do a strange shim. I'm not calling it code strange, but
yeah, I mean, so like a very complicated, thing to emulate some very particular behavior would be undesirable.
And so I think the first step in this direction would be to just separate out pure bindings code. And in our experience, the best thing you can do is auto-generate it. There's like you can also write tests for the generator. There's like one place where you do the mapping, and then describe in IDL what you want to expose, and then have a separate place where you keep all the non-standard stuff.
Yeah. So, okay, just to make sure I get my head around it. Any of the objects, like we said, created from directly. If the JavaScript layer though would, if I understand what you're saying correctly, that the JavaScript layer wouldn't actually be working with V8's implementation of a promise. They're basically working with our wrapper around that, right?
What do you mean by JavaScript layer?
So I have some data, a node module where your JavaScript I create a promise.
Okay, so so you have a node module and you create promises. It's like the only way to avoid to include the V8 API is essentially that you have a node promise, right, which has a stable API. And so you use this node promise. When you then pass it to JavaScript, Node knows how to unwrap this node promise and link it to a V8 promise.
I think you're talking about the C side that we always have our wrapper.
Yeah, we have a wrapper there.
Just on the C.
Okay, so just want to clarify something that I like the idea, but so yeah, the C++ API of add function to microtask queue, right? And then in JavaScript you basically have .bin, throw a function to .then, it throws it in the microtask queue.
Yeah.
Problem is that the microtask queue is a black box completely. We have no idea what's going on there. Other than we can say run it, and then it will run a completion, and that's basically all the time. If we wanted to be able to wrap that, I feel like we'd also need to know what's happening in the microtask queue. So I feel like some of the API there is missing from being able to either we hijack that and run like everything through the next queue, or just wait until we have additional APIs that allow us to have that observation. And sorry, I can be way off, but I just wanted to make sure I understood what you were saying.
So there's two issues being conflated here. So the microtask queue, is not a feature that exists today. So it doesn't make sense to talk about it right now. So the microtask queue, putting things into having direct control over the microtask queue, is not a feature that exists today. That's not something that modules can do today.
Yep. They can throw functions.
But having introspectability of the microtask queue.
Oh yeah, no.
So that's not there.
No,
Right?
at this point, I think it's just more, and we can go into the whole.
Yeah, sorry.
It's more understanding what the separation that you're suggesting, with what node would need to provide, which is essentially a wrapper, as a native layer, so that we're not directly exposing model developers to the native implementations of these things within.
I guess that's like the only way you get a stable API that doesn't change.
Right.
Yeah.
But the question is whether or not you even want to expose promises directly to C++ module objects. Actually, I would like to see concrete use cases. I mean, you could write JavaScript. You could write JavaScript to it.
I'm sure you can find a reason.
Yeah.
Well, but does Node Core want to support those APIs in an API compatible way? That's the question we have to answer, right?
But and that goes back to the question in terms of us being able to us with Node, being able to standardize. I mean, what are the language features, what are the capabilities we're exposing to model developers versus what are the differences in the backend VMs, right? So if there are subtle differences between the way V8 is implementing promises versus Chocolate implementing promises, having this layer in here allows us to isolate that, right? And more strictly define what is the behavior Node expects, right? The behavior Node expects is what we are exposing.
Or just not expose it at all.
Right.
I think one of the key things with separation is one thing, but the other one is constraining. Say, no, your native API is this smaller, much smaller set. You can understand and know what the behavior. We were talking about those things like maybe it works because Node Core doesn't depend on it, but who knows what some of these modules going to do.
Yeah.
Whereas if we have a more constrained one, we can understand what they can and can't do. So making that small and only adding things when we really think we need to is probably a big principle.
It gets back to the least common denominator problem, and it runs the risk of limiting innovation if we're actually.
But I don't think that
the limits of innovation that happens sort of on the API surface. If I think back about the past 5 years, it's not that there has been, a ton of really nice features coming out of API. The APIs got slightly faster. Buffers got invented and then, killed again, more or less. And that's kind of as far as it goes, I think. So.
Like you proposed earlier, we would start with very basic capabilities and how you can describe an object. It's probably a fine starting point. You won't get all modules to cut over the new API overnight anyways.
No, we're not.
That's true.
From doing it the old way, right?
Well, not for a long time.
Right.
Yeah. Can we use the environment? Does every native module get access to the Node environment, and meaning Node : environment? And in which case, when we have classes or some of the stuff that's in V8 exposed through environment, you could say new environment : whatever it is, object, new environment, number, etc., etc. And that's a generic interface from something that the native modules already have access to. Of course, they could use innate V8 objects instead of environment objects, but we already have something of an abstraction layer to start with.
Where's Ben when you need him? I don't know. I mean, I think it would be to a certain extent possible, but whether it be practical, hard to tell for me.
So it's like, I mean, like at the point where people include weight with age, and the experience is they will use the most egregious function they can find, and it forces you to recompile on every update. So like getting a stable API towards module authors requires at least, you know, having a way to not include weight with age.
Yeah. I agree with you. So back to you were talking about machine. There was one more thing I wanted to ask. Or like maybe there's other people, but can you describe a little bit like how like handle scopes, how that emulation is?
Object lifetime and handle scope is kind of the one of the harder part of our shim. V8 has the concept of basically you create a handle scope, and then whatever that's like you've gotten from it, you basically is included handle scope until that handle scope kind of exited. Mm-hmm. We emulate and Chakra has a considered GC, so whatever is on the stack, it's fine. Mm-hmm. So how we emulate it is basically our handle scope has like a couple of fixed slots on the stack that you can actually put stuff in. Once you exceed that, we create a JavaScript array and put stuff in there to keep those alive. Right. So if you have a large handle scope, then we'll have a performance penalty. But from our data of running unit tests and a couple of modules, generally it's small enough that we can put it in the stack. I think we fix it to 6.
Okay.
I have a question.
I'm asking because, okay, it's my personal preference. I think like for a standardized interface, as I said, C is easier, and like you know, JSRT is closer to like also the other engines such as Duct Tape and SpiderMonkey have very similar APIs. But what I would not want is for our abstraction to presume a conservative GC and only work with that.
Right.
And so when I looked at your API, I wasn't sure, and clearly this is not the case, but what I assumed is that you would emulate handle scope by just explicitly invoking JS add ref whenever you add something to a handle scope, and when you destroy a handle scope, JS down, or like JS release, whatever it is. All those objects. Clearly, that's not the case because you're like, well, we are conservative. I just need to store the pointer on the stack here.
Yes, that does definitely make use of our engine characteristic, mostly because of performance. AddRef release totally would work as well, and I think our initial implementation actually uses those.
Okay.
So at the minimum, that is a viable route. But if you really want to have performance, that might be a little bit much.
Okay.
Depends on the implementation, of course.
So for just everybody is on the same page, for us, the point why we need to have locals is because at any point the GC can move the objects around, and it needs to update all references to those objects, including whether they're on stack or in the register file. And so to be able to tell apart a random double value that happens to be on a stack from actual pointer we need to update when we move an object, we rely on these types.
Well, I mean, but you could assume, you could just imagine an alternative implementation where you basically have a side stack and you implement all local routes as like a linked list that just grows and shrinks, whatever, or something like that. Okay.
Right. Like a side frame kind of.
Yes. I don't know if that makes sense.
For those cases, would the add ref remove that calls be much overhead?
Well, I mean, it depends on the implementation. Like if like add ref actually increments a number, it would probably be fine. If it finds like a slot in some array which needs to be grown every now and then, it might be too much overhead. It's hard to tell. I mean, it depends on the implementation.
Right, it depends on the implementation.
I mean, the downside of it seems very obvious to keep like a number, like or like a reference count with every object, but it is pretty. I mean, it's bad for memory usage because that might end up being a 64-bit slot on a 64-bit machine, and so that means that every double is now twice the size, right? Because in addition to the actual value, you have a reference count, so it gets a little.
So now we're benchmarking even just bumping up the pointer in an already existing handle scope. So what you have to do, you have to go from the handle scope to the actual list of pointers and find a new slot there, and that is already showing up in perf profiles.
Okay.
And so there are places where we pre-allocate handles because we know, for example, the return values in the function callback info, we know you need a handle slot, so just pre-allocate one. So you don't have to do those 2 jumps to get to a new handle, but only one. And that shows up in perf profiles.
But is there anything that would make, if the API was actually defined as a function that doesn't add and remove as opposed to create the local, would that cause too much performance overhead? What you're talking about sounds like the implementation detail of how you implement the add, but it's just having a function which does the add.
No, that's fine. I mean, the local, what it does in its constructor and destructor, it registers itself the handle scope of dealers. So, right. If you do a function instead, the only thing that changes is I can forget the removal and then we'll go install.
Yeah. Well, I mean, you could imagine how the V8 model maps to a C interface, right? You do JS create local and JS delete local, more or less.
Yeah.
You can.
Right. I mean, it's the work we do in the constructor and destructor of the local.
Yeah, exactly.
Just making sure that we don't think that that's going to be, that model means that what we've done on V8 isn't going to be workable.
Well, I mean, I mean, we don't know, of course, but I don't think performance has to be an issue, but what is the question is what, they're fairly different models, and so if you want to come up with an abstraction, you want to come up with an abstraction that works for both, right? We don't want to tell V8 hey, you have to have a conservative DC now, and then ideally we would not tell Chakra hey, you have to do this complicated kludge where you create a global, pool of roots and add every local to it. Somewhere in the middle, ideally.
Actually, on the counter side, the Ruby has a conservative DC, and they don't have any concept of local scope.
Mm-hmm.
So native modules on Ruby, if the compiler is aggressive enough, the C compiler can crash just because the handle is in a register.
Mm-hmm.
And the conservative DC just cannot find it.
DC doesn't look in the registers.
That's weird.
So
sounds like bug.
Yes.
You think that the registers would either keep their value or be popped on the stack.
So the reason is it's edge cases where it's after a call, so you're not sure if the value in that register was clobbered. So it's in a register, it is a reference, but
that's why it is a conservative GC. If it might be a pointer, you assume it's a pointer. But I mean, I don't know, of course.
Yeah.
We actually have this problem with precise GC, and what we do, we have Clang plugin that scans the entire generated code whether subscription can ever occur, and then you manually have to fix it up. And on the C++ API, we have those public local handles that just hide the problem. They're never giving you the real value.
Okay.
So, and I want to make sure that we're, that we're getting somewhere, where we have not just a shared understanding of what's being done here, but what do we need to do next? What are the changes we really are settling in on? Whiteboard. Easiest thing. Apologies for those that are on the phone. They can't see this, but so with Node currently have everything in live, right? We have process finding, right? And then we have things like that everything is basically node stores, right? Things like file, or what do you say, FS, FS module and buffer, right? And underneath this, we have V8, VBB, right? And then our other dependencies, right? And part of the problem up to this point, so if I have a native module, part of the problem at this point is that this abstraction bleeds all the way through, right? And bleeds all the way through here as well. Right?
The same is probably true for the other thing.
Don't see anything.
So, let's
just
just focus on,
Yeah, no,
it's true. Let's focus on this one. What we're trying to do. So, what Trevor was talking about, and correct me if I'm wrong, but the suggestion before was we take everything this here, we basically standardize and get a better definition here, and make everything below there, pretty much VM specific. So that we have our V8 implementation, but if Chakra comes in, wanted to come through and not have to do the shim layer, what it would do is just implement everything below here specific to the Chakra APIs, right? Is that accurate? Mm-hmm. Okay. So the key challenge with that is, because some of the conversations that have come up, is that there's a significant amount of logic in here that is specific to the way Node operates. So example being how we handle our file system APIs. We don't want to have Node on Chakra implement FS reader in a slightly different way than V8 would do. Right? We don't want to introduce subtle differences that way. So we would probably have to standardize half of this, right? Some degree of functionality here which is shared among both implementations, right? And if we did that, we'd still have to define some API with level that would extract it. If we went with that approach, we'd still have to have some API or ABI standard, right? Honestly, it's more of a standard.
So I've got a bit of a hard time following. I would have assumed that, isn't like the first problem we need to solve how to insulate the native modules from all of them?
Yeah, and that's really, how do we keep this from bleeding all the way through? Right?
And that sounds like a problem that's independent of what we do internally in Node.
I think it's related. I think it related, and also gets back to what you were suggesting in terms of not letting the objects and things that we're dealing with here bleed all the way out.
Yeah.
Basically providing that wrapper, or basically would be providing that wrapper in this, right?
Yeah.
Like 4 promises, right? They exposing a node promise rather than a promise, right?
Or we could go to or we don't have to do this at all for a good chunk of the modules, but go to the bindings layer for native modules.
Right.
Yeah, so getting people to write JavaScript rather than writing native code or doing fast FFI, and those are another way of doing the same thing.
Well, getting people to write JavaScript in general was always a strategy, just not always feasible. And FFI, I agree, would be, at least theoretically, would be an alternative.
It doesn't cover the use case of shared native code that polyglot systems need to be able to happen.
So I'm not sure the precise use case, but the use case of when I already have a C library that I want to interface with, FFI does cover it, right? You just need a way to get. In fact, my JavaScript developers, I don't want them to write C code or C++ code at all. In fact, they don't want to do that either. All they want to know is, this is the library, I just want to call it. Just do it for me. Don't make me think or write C++ code.
If you want to see
Uh,
straight up.
So existence proof, LuaJIT does really fast FFI. Ideal is really
Okay,
fast.
so you're not saying it is really fast.
Well, currently there is nothing, right? So it's,
But
I mean,
from what I'm told, they, as will implement it for performance.
okay. I'm not surprised.
yeah, so it's doable. There's a code from Microsoft that basically uses the C compiler to do it. There's many different ways of doing it. What I'm saying is an API is not the only way to solve this problem for native modules. And by having to create this API up front gives us on a much longer trajectory to get to a point when we're integrating the native modules that we could be doing.
So we can get module developers sending, going through basically the process of finding more things going directly to native. So that's the thing.
No, I'm saying
No.
I'm saying I want native module authors to use a faster phone function interface.
So basically what Avia is proposing is like, basically what we do now is you have to, in order to expose your C function to JavaScript, it has to have a particular signature where, it takes JavaScript argument types, returns JavaScript, etc. You have to write a wrapper in C++ that, V8 understands. If you do FFI, basically, you can just pull, in theory anyway, any C function directly from JavaScript because it is smart enough to know, how to create stack frames, how to, convert argument types, etc. I mean, I think there's actually a lot more complication here than you might expect, and people might still have to write C++ wrappers.
There are some use cases for which you still need to write C++ wrappers, and I think that's fine. It's at that when Node Core is ready with an API, those problems we can solve too. I'm saying we start out by saying we need to come up with a perfect API, an API, and then give it to native module authors. We're already putting a long trajectory ahead of it.
I guess that's true.
And with the fine, how does the callback from, I guess there's no callback from the JavaScript because they didn't know anything about JavaScript. Like you call C function,
good old
you have to return variable.
Yeah, so if you're interfacing directly to a C library, that use case doesn't require that C library, your Oracle library driver, doesn't have a concept of JavaScript. It gives you a C API and gives you the database API, and that's it.
No, but Michael Dawson is saying, like, well, sometimes, a C library might expect a callback, which is a C function pointer signature.
Yes.
But it would be difficult to pass a JavaScript function.
Not necessarily, right? I mean, the FI could just have a JIT, a trampoline, and give you a raw C pointer to the trampoline.
I mean, yeah, that's a good. I agree.
So in order to actually require meet the requirement that we don't want native module author to recompile, you have to generate those dynamically. So basically, you have to specify your C signature and give it to the engine itself to generate those chunks when it sees them, when it imports the native library.
But I think we might just end up like sort of having different opinions about this forever. I mean, I don't disagree with FFI that it would be really nice to have. The only thing is that I think it's technically actually much more complicated than what we are trying to do, because the JavaScript interface problem is kind of well understood. Like there's like 4 engines, they all have their API, they're all not massive. The API service is typically not massive. And for FFI, like we're at 0.0, like we now have to decide how we can define a pack union, in C or in JavaScript, and like find a way to fill that, or like how to deal with native pointers. And there's a whole lot of problems that and probably we can borrow a lot of ideas from other languages, but nonetheless, like there's nothing. And I think data trajectory is actually much longer finding a fairly minimal API that you can use from C++.
Cover all the use cases, like the 4 use cases we talked about, I don't think it covers all of them, right? Like the ones where they're trying to talk back to the runtime to get more info, like.
It's kind of like the 4th use case that depends on EVM by giving you extra
Right.
things.
Yeah, I think there was also a
And
lower
that was
priority.
like, we you know, sort of, as soon as we mentioned that one, that was like, that one's never gonna really get encapsulated
Yes, yeah,
by
it's-
definition,
Yeah.
right? In
Yes, the other
their use cases, because it's interaction directly. Yeah.
So.
The Chakra Consortium, you know, is it conceivable to do a rough proof of concept? Like, if there's enthusiasm to, you know, go and go try it, like, the level of effort could be.
What do you mean by it?
To go and implement, you know, FFI.
So the dynamic FFI requires support for mid-range to generate code.
Okay.
So I think to me that's the work that's complicated. There's also you have to figure out things like what is the representation we're going to use to communicate, like how are we going to represent these things in JavaScript and do the data type conversion. But those are just decisions you have to make. The harder part is dynamic coding.
And the V8 at present doesn't.
There is an example in V8 where there is a thing called, it's experimental, don't use it. It's a fast accessor generator. So basically, it's a mechanism you can use to generate code dynamically. So, and don't.
And in Chakra, we have to interop with WinRT. So we have our own system of parsing .NET metadata and generate funcs for those.
So from a module developer's point of view, I created a native module. What would I have to provide in order for the FFI?
So what I would like is that I write ES6 modules.
Goodbye, Fedora.
So basically, you just define the interface you expect from that library that you're interfacing with, and that's it. That's all you need to do. And the module loader in Node understands that, and basically you can generate your stubs for you.
So basically an IDL artifact in my.
Not even an ideal artifact. It is just JavaScript that you're writing.
But I think it's definitely not impossible, but more like convenient API or convenient FFI solutions typically are able to like parse C header files or something, because if you like, let's say I'm gonna ask you to look at Windows.h, you know, and define, you know, and define in JavaScript all those C interfaces, like, you know, you need some antidepressants.
If we had a well-defined mechanism for how we describe these things, then somebody in userland will create some tool that would make it a lot easier to look at these headers and find that, you know, and you'd have some dependency that your code depends on for making that easier, right? And for a lot of these that are pretty well defined, I mean, you end up with these modules in PostShadow and NPM that provide that already do that for you to a large extent, and you would depend on those, and 90% of the work is done for you. That's what I would expect. That may be unreasonable, but
I mean,
I think it would be like, I think it would work for some stuff, right? For in particular things as like image magic or like an actual library that people are trying to find, it would be very convenient. But like for stuff, you know, for modules that already exist where they do, you know, they have implemented this like V8 interface, and you know, you do like a bunch of stuff in the function body. Like it's not a wrapper, but it, you know, does something such as what's going on, you know, let's say in serial port or buffer util, right? I think it would be much easier for them to switch to a slightly different API, which is standardized, than to sort of, turn the thing on their head so that it becomes an FFI system. So their C functions become more vanilla, right? And they use it for using FFI. Because it is even harder to imagine that they use FFI to call a function which has the signature, const arguments by reference. That seems very unlikely. That uses data.
There's another point that I wanted to mention, which is that actually I would really like to avoid having the compiler toolchain being involved on npm install. It used to be a very big problem on Windows, especially in the past, but I don't know if Bash on Windows changes it. But Node users continually get a lot of trouble on Windows trying to compile because they don't have the toolchains available by default. And so that's the other reason why I prefer the FFI approach, is because I actually don't want to compile things on deployments.
I think with the updated API, you can get the same thing.
Right. You don't require recompilation, so you can do.
Well, there is still there needs to be a mechanism in place to get precompiled binaries for different platforms to deploy.
Yeah.
And so
I think nobody here really disagrees, but it's like the wrong venue. You have to like focus.
The thing is, we're building a system to interface with native code, and if we build into it the fact that it's going to require either compilation or provisioning of native modules, somebody has to solve that problem rather than us. And we're just kicking the ball to somebody else.
Well, I mean, I feel your pain, and but I have no time for it. Like for a long time, I wanted, for example, to ship Clang with Node, and since Clang supports Windows, just use Clang on all platforms, so it becomes much more uniform, like wherever you do things, and you wouldn't have to install Visual Studio because it's a pain. You have to download it separately, whatever. But it just, lots of work.
You're asking NPM to move closer and closer to Debian, which I am not opposed
That's
to.
not what I'm asking.
But to ask them to build every new version and release of every module.
I'm actually asking the opposite.
I think what you're asking is people can just ship binaries.
No, actually not. What I'm saying is, for majority of the native modules out there, which are just talking to a C library, why do they have to be compiled?
Well, you still need to compile to the C library.
Because
C library itself,
but not against Node.h or V8.h.
Sorry, say that again?
You would still have to compile it for each platform, like a Dylib for Mac and the SO for Linux, whatever else, but you don't have to compile it again against V8.h or Node.h, right?
Right.
Well, when you do an npm install, your native module still needs to be compiled or provisioned some other way. With FFI, that just goes away. With faster FFI, dynamic FFI, that goes away. There is no.
That means you still have to library binary if your library depends on something other than V8 or anything in Node, like image library, right? You still have to download the image magic binary in order to run FFI.
But that's an operating. So it's an apt-get of your image. So apt-get install image magic. It's a different. It's not the responsibility of Node to provide image magic.so to you. It's a job of the operating system to provide image magic. So when you're provisioning your production system, right, or you're provisioning your image, it's not the job of Node to give you all the dependencies, libc.
That's such a pain in the ass, man.
Yeah,
you have so many different platforms managing those dependencies so many different ways. You have to have the module know how to request that module on each platform.
I think there is a little bit of a philosophical difference here, because what we traditionally did in Node, and in defiance of people that maintain Debian, for example, is bake everything into it so it always works.
Right.
And the it just works philosophy is kind of important to us, which is also why we, for example, bake in OpenSSL, and that in particular trips up a lot of distro maintainers. If you look at the Windows specific issue, which is where the compiler issues are usually the most visible, there isn't really a way to install an ImageMagick DLL. I'm sure maybe if we're lucky you can find it on the ImageMagick website. Otherwise, you will still have to compile it yourself. So a solution where we basically just shift the problem so it's no longer on our table, but it's still a problem, isn't really a solution.
Well, so the thing is, today we don't. So today if I write a native module that interfaces with ImageMagick, right? Node doesn't help me in any way to help provide ImageMagick. So that doesn't change. What I'm saying is,
well, I mean,
my native module doesn't.
I disagree, because what a lot of people have done, and I'm thinking like libvorbis, I don't know, like extreme things where, you know, they set up their native module such that, you know, it just is, you know, it's compiled in its entirety, so like not just the glue, but the library itself at install time. So like, you know, it means that you have to port the build system to JIP. It's kind of a pain, but then people do it anyway, and then once you get to that point, it works, right?
Should just do your Clang package.
Well, there's simpler
yeah, I think
Magic though also. Like there are things that people have written C-level libraries for use in Node. Like, right?
Yeah, that's true. Yeah, so like the buffer util stuff is like, there's no, so you wouldn't get there with FFI because you would,
Dora had a suggestion in IRC a little bit ago that maybe an interesting thing here about LLVM bitcode here, and like something that could be an option to support native modules, but also hit, you know, multiple targets for platform and engine compatibility. Is that something that?
Isn't it a really interesting idea? The question would be if it makes. Yeah, I mean, there's not much. I don't have any objections. Although the question would be why wouldn't we do WebAssembly? Well, we discussed that already. Like WebAssembly doesn't really have a way to interface with other native libraries at the moment.
Are you talking about the issue like that we have to compile for different OS APIs, and that's why like a bytecode kind of thing would help?
Yeah. I think this was both for like platform and engine, like so that like if it was abstracted and it was just an LLVM bitcode, like that could solve the NPM problem too, because you could just ship the bitcode in an NPM package. It wouldn't involve any compilation on install, and then you would just have the bindings for the LLVM bitcode inside of Node itself, and then the engines could take care of how to handle that.
I think that solution has interesting characteristics, but I think that a lot of C code and C++ code, when you do cross-site form, there's a lot of if-defs and stuff like that. I don't think that can be encoded into the bit form.
It wouldn't solve more difficult problems with the compiling and stuff. We'd still have some class of stuff we'd have to compile it and install. So,
yeah,
I don't think it's on purpose because it kind of just shifts the problem, you know, a little bit, but doesn't actually fully address it.
But I mean, like in a way, I also don't really. I mean, I don't think we cannot really solve all the problems out there. Right.
And I think that one of the major problem with the user case for native module is that a lot of people don't install the compiler. So if we can actually, so if we,
yeah, but you have to talk to the lawyers at Microsoft.
Well, maybe
so,
we're talking about the OS API here, but that's kind of orthogonal to everything else.
Oh, sorry, I was totally kind of
so if we can actually move the system so that they can do binary distribution easily, then that would be great. And one of the biggest problem with binary distribution is that all the Node versions API is different. So you have to, on top of all the OSs, you have to put all the level of Node if you want to have those compatibility. So if we
have issues with NPM already,
right?
Don't want to add.
Right. But I think that if we abstract the engine API out, then we solve the multiple node version problem.
So if we so here, I mean, we've already identified, one of the key problems is the fact that the V8 APIs are bleeding all the way. There's not a good enough abstraction there that we have to stop having this API bleed out to module developers. It's the only way that we're going to actually isolate module developers from having to recompile this thing, right? I mean, does anyone disagree with that? So probably the only solution that would make sense, at least for module developers, when I'm talking about inside core, is for, let me say this is Node, right? Is for Node to provide a, we might get a bit of for Node form of an involved demand for abstraction API, we have to provide an API here, right?
Yes, and the difference with NAN is that the API goes in Node and not in the module.
It
The
covers
abstraction.
the whole thing.
Hmm?
And it covers the whole thing, right? Like,
Yeah,
yeah, it doesn't.
It doesn't leak any like things that might still change. Yeah, that's true.
So basically, the goal would be you cannot include V8 or H. That is just not possible anymore.
I mean, like there would definitely. I mean, I think that's too far on the horizon, right? Like there will be a fairly long time frame where people will need to be able to do that because where we can't expect them. You know, we release Node 17 on like December 14, and then like on December 15, everybody has changed their models. It isn't gonna work.
One of the things I want to get through, like for today, is the idea of what should we do tomorrow. I'd really like for us to get to, well, how the hell do we actually do that? Yeah. And I think that's part of that. It is how would we do this so that it's actually reasonable over a short period of time?
Yeah.
Right? And I agree. I think it's a non-trivial problem in terms of how we would do that reasonably.
So I would like to maybe this is I have no ideas how to do this, but let's think about it a little bit. Like, okay, my preference is clearly to provide an abstract API because I believe it's like the most actionable and like the most feasible in the short term. Ali is proposed FFI, which I find a very good idea, but I think eventually the question becomes like how can we validate, but realistically neither of us knows, right? Like it's kind of speculation, matter of taste to a certain extent. How can we validate that we did the right thing? Can we do like an MVP, if you will? Can we get somehow gather community feedback on on a prototype and see if it makes sense what we're doing? So I would think there's like a couple steps involved, and can we identify them? Something fairly minimal, maybe a pull request to buffer util. That'd be something. But we could do a community poll where everybody and their cat get to say yes or no to this API. Maybe that's an idea.
Try to prototype a few native modules in terms of the
Yes, I think something like that.
But I think what you're saying is maybe we need to say, if we agree that the two good possibilities are one is this API and one is FFI, we need to do some work on both of those.
Prototyping.
And then have a way to compare them to say, oh, actually, one turned out to take 10 times longer, so we're finished one and the other one's not even halfway there. That's some information. Or, yeah, we've got them both working, but this one has disadvantages or not. So I think it seems like we're in agreement we should do something in this area, and those are the two candidates. So maybe our concrete next steps is to say, let's get working on both.
And the reality may be that it's not one or the other that ultimately the solution is. It's some combination of both.
Right.
But you're right. We have to scope the issue. So why don't for tomorrow we dedicate at least part of the time to working out both of those. Just kind of put our heads. We can split up into smaller groups, whatever we want to do this, and just kind of get a rough sketch. What would the FFI thing look like, and how would we actually, get a minimum viable product for that? And then how would this API thing work? We're basically instead of include V8H for something else. How would that approach work, right? And let's see if tomorrow we can actually hammer out some of those details, even just a preliminary before we go off and write code. Does that sound reasonable?
Yeah, a small one from the IRC. Jeremiah just wanted to mention that FFI may not be optimized enough for low power hardware.
Yeah.
Just be aware of that and think about that.
That's actually a good point.
But I mean, I think it would be, in theory, it can be fast enough. Like that's kind of the other side of it, right? Like it might not be, the Node FFI might not be very fast, but that's because Node FFI cannot stick its finger in the JIT, but the V8 team might be able to do that. So.
Yeah, implement FFI.
No, it's just,
Maybe the third thing we have to add is capture the use cases we want to test it. Right? Like if there's concern that in this particular use case one or the other might not be good enough, let's capture the different cases we want to compare them against. Right?
Yeah, that we can pull in the benchmarking work.
Are there ones where we think there'll be challenges for one or the other, and
would that be a subset of existing native modules, or if it's something beyond?
Well, it may not even be modules. Like that could be a good case. Is we could say, let's look at the existing ones, right? But another one would be like particular environments, like small machines with very lower processing capabilities. There's some reason why one or two approaches doesn't work there. Like I don't know the list on my head, but it's
essentially
those different things.
What the strategy is for actually benchmarking and evaluating.
Well, it's kind of like what cases will we be worried about? If we were to do a benchmark off, what things would we try and benchmark and why?
And today the compile step on those low power machines is already
right. But is that disadvantage one or the other? Maybe. I don't know.
Yeah.
So to Ollie's point, I mean, do we also want to take some time tomorrow? Like I said, I mean, NPM has enough issues as it is already right now, but do we want to take some time to investigate strategies for eliminating or reducing the compile on install step so that we can try to avoid the problem in the first place, right? So the users don't have to recompile modules.
But isn't it like both of these approaches address? Like they mean that you don't have to recompile on install. You could pre-build a binary, whether it's one that's already built or one that you build with this API, and then you should be able to reuse that binary.
Well, yes, you still have to compile for every platform in particular. It just you don't have to redo it every time Node releases with a new
Right, but it's a question of whether you have to recompile or whether you have to compile in the first place. And I think the point, I think the point was to try to avoid having to do the compile in the first place. So when npm install, it doesn't have to do that post-install compile step.
Right, but I could, if I have a stable API, I could compile something into a binary, and then I never have to actually compile it on install. That way npm just
so not all users are using that workflow. So some users install, so they would bring up a Docker image on their cloud provider, and they would do an npm install.
Right.
And that will compile on their deployment machine.
But you don't have to do that. You could recompile the binary, you say an npm install it.
Agree, but not not all users do that.
Well, I think a bit of the issue is currently that it's not just the fact that you have to compile for every platform is like a big showstopper, in particular in this community where people, we have a large user base of Windows users, but like the developers are primarily not on Windows, and like people are not willing, or it's too much work for them to actually pre-compile for this platform. So
it's not available to them to actually go out and do the compile.
Exactly. So like we could brainstorm about solutions for that, but it would probably involve cross-compiling. It'd be like we open a can of worms here because there's also like no standard libc that works across all platforms. So cross-compilation makes it a little hard. We could take the Microsoft libc, which also doesn't the license get in the way, and for glibc that's.
Well, hey, now that Linux runs on Windows.
I mean, so the reality is like we could. GNU stuff is the same issue. So we could take something from FreeBSD and try to port it. Like with it, that's. It has a couple of years.
There opens a range of issues. I mean, one of them that had been discussed at one point was having a build service that would go off and build these binaries for developers.
Mm-hmm.
But I know part of the issue for that had to do with just simple licensing.
Yeah.
It's like whether it's even legal to be able to do that. You have no idea exactly what it is we're building in it. So I think there are a ton of issues with it. I'm just wondering, for tomorrow, is it worth our time to go through and discuss that as part of figuring this out, or is that a problem we don't even want to spend our time looking at right now?
My preference would be to keep that out of scope and stop at the API.
That sounds like it could be another session like this.
Providing API really would facilitate any effort in that end.
Well, I think it's also like you need different people for that. Again, these are people that care about VMs. You need people that care about like standard libraries and compile your chains.
I've been working on a prototype for this build. So
yeah.
Solving that workflow is a much bigger problem involved. Even if you did solve that workflow, at some point you would have to compile, right? And having that stable API that makes you compile only once per platform would make that much more feasible. resources.
So, in terms of this API, so we're going to take some time tomorrow, to kind of basically work on for the FFI and also this API ability for module developers. Part of this, and often part of the FFI, the separate conversation is in core itself, right? So, it's framing what we're going to go through tomorrow in terms of core. Like you said, we talked about, Trevor was talking about, okay, that all of this would be, be in specific implementation, right? Or what amount of this needs to be common code so we maintain we don't introduce incompatibility between different VM versions and that kind of thing. It's conceivable that a good portion of that would also depend on this, or part of this API. The API deals with, introducing this this abstraction for like node forms, right? There seems like that is this intermediate layer that we want to introduce. Node itself could use that, and that could provide the consistency we need. Or is there another approach we need to discuss?
Well, I mean, I think it's a little bit like whether Node is actually going to use the APIs. Like, although I personally think that it would be a good idea, it seems contentious. So you want to kind of like, how can we prove that it works? Like a suggestion that I have is take a slightly performance critical part of Node that doesn't do anything very, for example, the HTTP parser binding. It does some interesting things, like it reads from buffers, it creates strings at a high rate.
That is such a mess. Have you looked at it recently?
Well, I mean, but that makes it a good challenge, right?
Something like that.
It doesn't do anything asynchronous as far as I know, but it calls back into the VM, which is really weird, but it does. And so, I think the service area is not that big, so we can, if we had an abstract API, and we could play with it and see if it
basically
works.
take some time tomorrow and kind of scope out, for this internal module, how would we iterate on this so that it actually comes?
Yeah, that makes sense.
It's sort of the same approach of maybe there's two ways. There's can you use the same kind of API model and then competing one, or maybe the end up wanting part of both is doing something at the higher binding level reasonable. So you propose one way to go with one, think of what can you proof of concept on the other side.
So I think the HTTP parser binding also would be a good candidate for FFI, by the way, if you come to think of it. So it'd be interesting to try.
So maybe there's the three pieces. You do HTTP with one, the other, and then through a higher level binding.
Yeah, HTTP
Except to know that. Yeah, we do something that's good for users, but not good enough.
No, but what I mean is, yes, so there's a couple steps involved. Like, first of all, you want to imagine what the API looks like, or just trying to rewrite the code using an imaginary new API. And then indeed you need an implementation, but the fact that you're looking at something concrete means that you can probably reduce the actual implementation that you need to a pretty limited set. You can do a couple days and not weeks.
So the experience we have in the embedders we have is that there's two things to the API. Like one is the actual calls you do, like set this property. But then the other thing is that you also want to have some wrapper types that encapsulate you from directly having to deal with all the maybe locals and whatnot. And I would expect that if you have wrapper types that work internally, you can also export them externally to this stable node modules API users. Right, then the question is if you also provide some kind of high-level API to interact with objects and do not want something, is this necessarily what we want to use internally? And in our experience, it's not necessarily the thing, because we want to have some more control internally. There might be some very basic things like buffer, which you don't expect a native module to do, but just use the buffer that's provided by Node.js. And so what we then do is that we, for the internal stuff, have generated, but like the handwritten generator for internal bindings. And then for external use cases that are like outside of the web platform, we just provide a convenience API.
And
Okay.
is there a problem starting with the lower level one and then later provide the convenience API, or is it like?
It is basically no. I mean, you can start somewhere.
Okay. So, thinking through the like HTTP, you know, I mean, it is a mess. I mean, currently the HTTP parse, you gotta look at it now.
But I'm also talking about the C++ side of it, right?
Yeah.
Like, so it's just, I mean, we can argue about like that the interface is weird and ugly, but it's not very complicated or big. So like it,
No,
I can
the way
easily
we
walk you
implement
through it.
it
And
is complicated and big. Like, just go take a look, dude. Go take a look what Sarah's done lately. It's freaking reentrant now. So it can be that's another reason why I had to make callback reentrant is because it can be calling back into itself based on circumstance.
And you know, I think it's one of those that I mean, it provides a. It is complicated, but I think it provides a really good use case for you know how we need to define these boundaries because of the fact that it does do some specific stuff. It's just a matter of whether we could actually look at it reasonably tomorrow and come to a.
I think it's okay. I don't really see any.
Okay. So what I'm curious about, you know, from the chakra team, you know, as you're going through and making chakra work on this, you know, if you had like a greenfield, you know, just you know, we don't have to worry about the V8 APIs. We wanted to implement this properly without a shim, right? What would that boundary look like? You know, or what would Node need to provide? I'm having a hard time framing the question. What would the architecture here with that boundary between Node and Chakra look like in order for this to be easier? Okay. Like for example, you know, in the HTTP binding, we have the HTTP parsers. We get a connection. We go out, you know, on the JavaScript side, we create the binding for the parser. We get a parser instance, pass the stuff off to it. There's back and forth there, right? Some of that goes through the VA API, some of it is the native stuff. Is there some way that would make that easier? Something that, you know, if you guys are going through it.
That's a hard
Yeah.
question to answer.
Yeah, and I
short.
think,
And like so, here's my point of view, biased point of view. If it is really a greenfield, if I'm just implementing, just basically marshalling between stuff, FFI definitely make it a lot more convenient to bring in whatever module you have and just describe it, and you have it work. You don't have to manually like marshal everything, but that does require you to actually define what the actual JavaScript API looks like that corresponds to the C++ API, and that is definitely the easiest way to bind native implementation, hands down. But that does require you to build up a lot of machinery, and also have really clear definition of all your APIs, which doesn't sound like, according to Trevor, not there. So basically, when we're going through it, we're just like, well, we're not going to touch that part because you guys are not going to change it, and we're not really wanting to, step on the actual natural evolution of Node, however you want to evolve your API. But we definitely would have some input on certain areas. So we take the perspective of like, well, what you have now, how we can easily plug in ourselves, and this is what we end up with.
Right.
Of course, even if let's say that like without the VA API, just translating all the VA API call to just directly to CalJSRT, we would change a couple of things, but most of the call would be kind of similar. Most of the changes would be like in memory model, of how you keep track of references, how you collect things, how you keep things alive. So memory management is probably the area of the most different between the engine in terms of interacting externally.
Where I was trying to go with the question is that if we went this idea where it was VM specific backends only defining, right? But we had some common set of functionality that could be used by both to define work. We would have to define what that API is and separate out the VM specific stuff from the stuff that it's currently doing. Right now, it's it's kind of a mess all mixed together, right? If we went with that approach, though, we would probably have to make fairly significant changes to Node internally for that to actually work out. I'm wondering if there's enough benefit for us doing that that amount of work to separate those things out further.
We're talking about a layer. So there's the RT whatever it's called, level API. We're talking about another API above that, right? I guess I don't imagine that yet.
So basically what it would mean is, so everything in Node Source right now is just a mix of the Node functionality and the use of the API, right? It would be taking out all the stuff that defines node-specific behavior,
right,
and pulling that out into.
So it's like providing another higher-level API that we say this is now VM-related stuff, so it belongs on the VM side versus the node side.
Right, and actually having to define an API between those.
And I'm not sure how feasible it is though, because like Node already in theory it's only glue. Like the actual crypto happens in OpenSSL, the actual I/O happens in LibUP, but the glue is fairly involved because we have we do lifecycle management. We need to keep a pointer with a JavaScript object and all that. That's actually where most of the complicated logic is. And so if you look at the object graph implementation, for example. And then there's a couple of areas where, okay, we do, we have a fairly large body of code that does string conversion because V8 supports Latin 1 and UTF-8, and we want, hex, and we want it to be able everywhere. But those things you can't really, okay, we can put them in a separate area, but then we become very dependent on engines only ever doing UTF-8, right? That's really not where we want to go. I mean, in my opinion, it'd be actually great if engines were a little bit more flexible in this area.
I'm having a hard time understanding things like what would be in there in that area that makes sense.
So I think there's only a couple small things, mostly defined in Node.cc that set up signal handlers for debugging and stuff. We could in theory factor that out, but it's not. It'd be a fairly small portion of the code. So.
And the other possibility is how much of what is Node specific currently in the data source do we actually move up to the JavaScript layer? So, for example, everything that's in Node files, right? There's for reading directory and these kinds of things.
No, but
is there any of that we could pull up by providing a better, maybe a binding for libDB and move a lot of that functionality up to JavaScript layer?
Well, I think so. I mean, the answer is maybe. So if you look at Node file, it doesn't really do that much. What it basically does is it's all basically data marshalling. So it looks at a JavaScript object, builds a C struct, and calls libUV, and then libUV returns. You get maybe some C struct back, and then you have to marshal it back to a JavaScript object. So what you could do is make that a buffer. Is you keep it in binary form, pass it in binary form to the JavaScript layer, and do the parsing out at that layer. That's a little complicated because the format of the struct is architecture dependent, so it becomes a little bit
would that take care of the majority of the abstraction layer that we're talking about?
Yeah, that's kind of like the FFI idea.
Okay. Well, I mean, also in the non-FFI version, if you want to have both things, right? You want to have something that takes care of going between C++ and or C types and JavaScript types, even for basic stuff like number or string. And then there's like a kind of methods and functions. I think you need both. It sounds like earlier what Shaq would do is to get like a clean space. But I think from the create point of view, there's also things I would do differently. I keep repeating, but like pulling out the interfacing with V8 into like this kind of type conversion and lifetime management and having this in like one place, and then everything else ideally being generated code. But you have like a high-level description of like, so basically any call you do from C++ to JavaScript or vice versa goes through an IDL, and you have a description of that you generate the code from, because that makes maintenance so much easier. Right? Like it's kind of you change something in the API, so either some kind of type management or like lifetime management function, so you go to one directory and click there, or you change something in how you go back and forth between C++ and JavaScript, so you go to the code generator.
Well, honestly, I'm down for any number of things. That's tomorrow we should definitely get into timeline, feasibility, because if we're like, this idea is amazing, but it'll take us a decade to do it, then I think it might be off the table. But yeah, like, I'm totally cool for exploring that one.
Yeah, the other thing is also what we should have. I mean, so the question was earlier, where should we start? So right, we can start somebody down in Node, but then it will take a long while before it benefits module authors. We can start first going for the module API and trying to get module authors to go to the stable API. But then it's going to take a long while before it benefits. It's more strategic vision of.
Okay. Yeah, when this is like whatever decision we do tomorrow or whenever, we're still going for FAQD, and the CTC will have to discuss that. Just so everyone understands, like, great discussion. Fortunately, you're not before it. But yeah, no, I'm really up for that, and I have a solid write-up so I can read over this, because to be honest, I'm going to be following what you're saying any time, because I've never heard of half those terms.
So in concrete terms, I think what he's saying is that handle graph and object graph, those are ideal. So you don't create objects, JavaScript objects using custom. And so Node.cc, so anything that works with a VM to come up and manage VM interactions, that's isolated from the actual JavaScript object.
I think if we went down that approach, I mean, we definitely have to scope it out and figure out how much time, what's the feasibility for implementation. But if we went down that approach and applied it generally across all of our languages, for that structure to nail it, I think long term it does improve the maintainability of what we're taking, and it'll, I think we'll accomplish what you've been trying to accomplish down the past year with having that very clear and well-defined binding.
Could also be that the binding there describes what you're trying to achieve, and instead of just calling a random set of V8 APIs. Right? So like the current set is it's a random set of V8 APIs. The easiest way forward to get this done is what you did is to just emulate the V8 API. But if you have like an ideal definition or like any other kind of semantically defined definition of what you're actually trying to achieve there, and then have a compiler that translates this down to whatever API. It's not just more maintainable. It's like if somebody wants to actually port this to a different VM, they have an easier time, but they're not just forced to reinvent the API.
Well, I mean, I think that like web IDL is like it's good for describing interfaces. Like I mean, that's what it was designed to do, right? Like a consistent way of like you define essentially one API and it's like well defined how it maps to JavaScript and how it maps to C++. And oh no, Java I think was the real use case. Yes, Web IDEA is from like the Netscape era essentially. But in Web IDEA, it's not a programming language. You cannot define the implementation. So like if you want to describe how fs.stat work, you might be able to describe the interface to fs.stat, but not how it looks at the JavaScript argument, or how it looks at like struct stat that it gets back, and how it mangles that back into a JavaScript object. So the issue becomes that if and that is still a lot of V8 API usage. So the issue becomes that even if you would be able to basically generate the boilerplate for functions like that, you would still have to write the implementation yourself.
I think you need to actually call fstat yourself, right? And then you need something that this is kind of like the second half. You need type mapping.
Mm-hmm.
Right? Like any type you want to reference into the IDL.
Well, I mean, it's a little more. It's not just type mapping. It's not. It is also. It is like, okay, we have this struct, whatever, that's internal, it's not exposed to the JavaScript user. But what we have standardized more or less is like a JavaScript object format, like that has all the information and how that sort of gets transformed from a C struct to JavaScript is not simply a type mapping. It's like, we parse out the flag fields, we set Boolean flags, we look at like a Unix timestamping, we build it into a JavaScript data. I don't know if we do that.
What we would do, first class, getters and setters, where you put in the timestamp and whatnot, and then it has a wrap method that gives you either existing or new wrapper representation of the JavaScript, and that can do all kinds of crazy magic to actually give you this JavaScript object. So not like a dumb mapping, but and also it's like a vice versa method. Usually it's unwrap something. So you get a JavaScript object and populate the C++ class, so you can continue using the C++ side, the C++.
Well, I mean,
it's kind of like we pull this out into one place. It's like this is how this specific type maps back and forth between JavaScript and C++, and so having it in one place just makes it more maintainable. I guess also easier to be implemented.
I'm not sure we have a consistent mapping, but I mean, this is one of those things, though, that we could do tomorrow in during the prototyping. I don't know.
Another example of the issue, though, is for the changes that it's made with VFS buffer, right? When we do an FS reader or FS watch, right? It's not just about mapping that array of file name stack. If encoding option is passed in the encoding buffer, but we return back to the JavaScript layer or an array of buffer opposed to the way of CTF. Yeah. There's certain behaviors like that need to be captured on the native side. It can't be described via the IDE, right? And we need to make sure that those things are defined well enough that we have two different VM implementations of this.
But I mean, you have the same stuff in the web platform, right? Yeah. You can say, I want to have some strings as an array buffer. There are elements where you can put in media stream, you can put in UL. So it's basically done by overloading, right? The IDL file say, either I'm calling this method with these types or that types or any. So that basically means you get in a script value, and you have to ask the script value, what are you? Are you dictionary? Are you? So I mean, in the case where you don't want to fully specify, you can go to any case and just ask the value, what are you? Just the thing is that you're not doing the V8 API, but you have the C++ API internally, just that matches to the V8 API. It encapsulates you having to deal with the
And for anything that is not describable by that IDL, it's just an additional specification.
You can just add the time to the IDL.
I can't do it.
So I mean, every time we run into a problem that we can't describe something in IDL, we just extend our local version to support the specific type. Nobody forces you to use the standardized IDL.
It's all like
we also try to document our differences.
Right. Public and documented. In many cases,
Well,
it's the
publicly documented.
publicly documented.
If you search for Blink IDL, the first few hits should.
So what's the output format? Like, what does your engine consume?
So the IDL files are compiled to C++.
Okay, so for different engine, you'll still do it.
Well, so if you would use this in Node, if you want to use a different engine, you would replace the IDL compiler. like outputs.
Okay, so the point is that, well, you can definitely like write it down and actually do it. If we have a engine API abstraction, then you can actually have the WebDL generated to it as well. And you can also abstract away the engine. But without that, native module, if they want to use this, you will still need to read it out.
So I wouldn't imagine that native modules goes down this IDL. But that they go down a more convenient and more stable, but probably more restricted API. That's right.
Couldn't we have put like WebIDL to define the interface into JavaScript and then like a header file, an environment variable that gives you access to the objects that you might need access from the native side?
I think for like the goal of native modules not having to recompile during stable release, required. So because for them we would define an API engine independent interface.
So bringing from the question, bringing up the native module developers, we already discussed more on that. One key question for Node Core internally is, do we really need to do anything? I know one of the questions that came up with is, okay, sounds fine. Microsoft go do that in your own port. And why should we actually have to do anything different in Node Core, moving forward? I think based on this discussion, there seems to be a lot of things we could do, right? What's the benefit of going down this route, right? What's the material benefit that benefits Node and benefits Node users? Why we would go down this road? It's going to be a significant amount of work, a significant amount of change. So ultimately, what's the benefit?
I think what was called out earlier was around the innovation, particularly if there's different environments where you might want, we might find about optimize the small LPs, RGs, and the ability of someone who wants to build something like that and have it work with Node. And so, people can do it today, instead by forming it, but can you make it so that it's easier for them to do that, so that the innovation gets into Node as opposed to, they can do it despite the hurdles there.
I'll give you another one. So the benefit I see out of this, even if nobody's going to innovate, I don't know, maybe they would want. Let's not assume that. Even if even if those benefits are not there, I think we need to insulate native module authors from the view. I think that's a call of action today, and that's the reason why we should definitely attack that problem.
I think we're all agreed on the native module side. I think that turns going on to the step beyond that. How would we justify that?
For Node Core, I think there was going through the threads on the PR and the roadmap. There were certain benefits that people had called out, and I've listed them out. I'll read them. There's a centralization and standardization of multi-PM effort, which is happening anyway. So an effort like this would kind of centralize that. Standardization of APIs, that's kind of a side effect of this. Yeah, and this will allow Node.js to adopt to V8 versions across different releases as well. Normalization of native APIs. So I mean that's the module developer case. Extends the reach of Node.js to platforms where V8 not supported, or there are other VMs that could be optimized for that.
Like Power and
That one,
ZOS.
I don't agree with that one. I think that's already blocked out. So to me, that's not a very strong reason.
Yeah, I mean, I think these were reasons which were expressed in the community thread, and that's what we have kind of collected. So because you asked that question, I thought it would be useful to just bring that up. Again, the innovation part where it allows multiple PPM vendors to be there to innovate on different aspects of Node, like debugging and stuff like that. And again, it keeps Node.js away from. And these were some specific things listed in the thread. Was keeps Node.js as a multi-VM platform, which fosters competition and allows.
Person thing about it is like if this activity of porting nodes to multiple VMs is going to continue anyway, by making it a more formal effort, then we have the opportunity to do it in a very consistent way.
Yeah.
Right.
Yeah.
So that we don't introduce incompatibility from
one effort to the
other. Yeah. So that we say this is node 7, whenever we deliver this, it behaves consistently across each of these, even if there are small differences or different innovations in what's happening on the back end. Right. We're not in a situation where one module posted in NPM will only work on node V8, on certain platforms, but it doesn't work over on node 7 Chakra. It's not in a very consistent way. Right? For me, that's probably the key there.
And there's a pattern of this need, over the arc of the last 5 years. Right? It takes Core, Avatar, Spider Node. This is just the most fully well-formed definition of that. So we can really take that and use that, leverage that as a straw man.
Many of those I would put that on its head, though. I mean, there have been these other efforts that have gone so far and then not progressed further, right? So, is it truly something that's needed?
The distinction is that those efforts have been outside.
Well, I think
they would abandon them because they couldn't keep up with the rate of change.
Right. So they haven't been collaborating with Core to align with Core's needs to see what the Core developers can provide, want to provide, and the big difference is this effort is really adding value to the broader ecosystem, where in many I'm really hypercritical of some of those other initiatives. They were kind of looking to draw away from Node.js and have it be something else, have it prove that they were a better implementation or a better platform that Node had wrong. And this is an investment in the Node.js ecosystem and our ability to grow the platform and to make it better. Above and beyond those considerations, we also have Node's interface to JavaScript and the growing importance of Node.js in the JavaScript ecosystem. So needing to represent those needs to the standards body. So if we aren't interacting with the platform at the language level and really testing and aligning ourselves there, then we're going to be consistently behind our ability to articulate the requirements to TC39 and other bodies, and we can't come in anymore moving forward and be like, oh wait, stop. We need to be also interacting with the JavaScript attorney and making sure that the needs of the Node.js ecosystem are heard.
No.
I mean, I think well summarized. The only other side. You want to go ahead first? Okay. Now, the only other thing I was saying is, as compared to some of those older efforts, right? There's also, of course, the commitment of the vendor to come out and contribute back to Node Core as well. I mean, which is also a big thing.
So, one thing I still hear about Node is that it's not committed to the enterprise, and I can kind of see that in terms of like how old it is, and the lack of tooling overall in terms of,
sure.
Java or a number of things that have been around for a lot longer. Now a lot more tooling behind it, and I'm not a huge concern, but I'm sort of out there as possible in terms of this whole like support, let's support in all the well, one thing here is unique from Java developers, how do I control garbage collector? And my response is large. Right. But that's me. But they want to have that tooling under their belt for whatever reason. And by saying, okay, well now you can choose whether to use the apps. Well, we don't have tooling to support all the
yeah. And I think I guess too, and I know Jordan wanted to cover on that is what does multiple VMs, what's the impact there for if you release from one single to another? What's the impact for debugging? What's the impact for post-mortem? What's the impact for the tooling environment here? There's a very real risk that we end up in a situation where Microsoft have the Chakra, they provide all the Chakra tooling. The only way to actually debug those, those versions of Node is to get the Microsoft system, right? And other VMs that have similar types of great. Theoretically, IBM these are tools in order to debug it. Then that's not really a benefit to the ecosystem. I mean, that may benefit IBM because we just help them tools, but it doesn't help the enough. So if we are going to go down this road even further, we do have to make sure we're paying close attention to how do we get enough consistency within the VM so that the tools can be implemented and used universally. And we need to make sure that as we're playing on this road, there's enough of a commitment among everyone that we're going to make that happen.
Yeah. I would argue though that we need to do that, right?
Yeah.
Node is at a point of maturity that the fact that we don't have an explicit definition as some of these layers impacts the broader all the companies represented in here are making massive investments in Node.js. Part of what we want is its stability and stability along the future. So we're going to have to go out and do most of these things. I see it as a group forcing function to a constructive.
Yeah, and just to add to that, one other point is like even when I look at the web client perspective, right? I mean there is surely a convergence that is starting to happen from a tooling perspective. Even in the web client space, for example, we have the diagnostic adapter for Chrome working with VS Code. We are looking at building a diagnostic adapter for the Chrome tools for the Edge browser as well. So there is that convergence because I think everyone has been realizing that so it's a couple of things there. It's the protocols that you talk, should be easily understandable. And once you have the protocols easily understandable and standardized on the protocols, the actual APIs, could be different and the actual innovation could be different. But, those are the basic things to kind of think about.
Like the tracing guy,
Yeah.
right? Like, I think it's pretty much that we're going to have to implement it together, and so like whatever call points it is, come from those. Are we going to start implementing that more, or the yes?
I mean, so essentially, most stuff to get in Node is either already in V8 or we are about to commit it.
Oh, really? Okay. So like now, Chopper could implement it, and that's cool. The concern is the fact that the data sets will look like the call sets
Different.
will be different, right? So people will be have different expectations based on what they're using, right? And I'm not saying that it's probably not. I'm just again bringing it up as a point where anytime you have any kind of difference or inconsistency, it's going to end up causing users some degree of pain, right? It's whether the tool is going to make it any easier dealing with that pain or not, or make it harder to deal with.
So I think that earlier, by definition, whatever your tooling protocol or interoperability is, it's only going to show the shared conflict.
So this gets back to the point that we raised earlier, and it's something I want to see if we need to take some time tomorrow to kind of hammer out as well, or we can take time today. I mean, we got about another hour and a half.
Yeah, I was going to push us. Maybe we can come to a point where we can have a definition of where something practical. We can actually go back tonight and hammer on some stuff and come back tomorrow with something.
So you mentioned earlier that one of the shared goals would be to deliver value to the ecosystem, and from my point of view, that basically means that we should first and foremost concentrate on encapsulating native modules from any change on that. And given that also repeatedly concerns were raised about limited, I mean, it's definitely not unlimited amount of manpower or willpower we can put on developing Node. That kind of raises the question whether, any kind of Node core refactoring, whatsoever, should be a second step after we figured out and actually delivered something to the native module.
I think we almost do it. We have to figure out what that. They are definitely just steps, and the refactoring of what is in Node is going to take much longer. We're going to have to figure out how to do that in an incremental way. So yeah, we're going to have to.
My impression is also that there's way less unclarity about what the properties of such an API should be. There seems to be mainly two approaches that could even coexist, either having enterprise support or coming up with completely agnostic.
Yeah, they don't prevent each other, so why not get two groups, say, go run and do your best and see who wins.
So it's and just down if y'all after this, I'm going to dinner and I may have to be interested.
So you're saying it's involved too.
We have the room all day tomorrow as well. If you want to take some time to kind of figure out what approach may work in the raw man, and we'll then get one of the part tomorrow. Not gonna. I think that would be a worthwhile exercise. And if we spent most of the day tomorrow just figuring out the native model stuff, and if we only have a little bit of time for figuring out what's happening in the core itself, then I think that's okay. But if we can, we should try to get to figuring out the stuff that's in the core. If there's anything there that we do need to do, we at least need to have an idea of what direction we're headed, right? So we come away from this understanding that, okay, there are concrete things we want to start to change in Node to make this easier for multiple input forward. Part of that, I think, is getting a clear understanding. We talked about it a few times of what
what are Node's expectations of the VM, right? And being able to document that. What are our expectations as far as debuggability? What are our expectations as far as being able to allocate memory for the buffer? You know, what are these things we expect the VM to be able to provide? And how do we ensure consistency there? So if we were going to go down this approach of having this, a version of Node that's built natively on the Docker API, how do we confirm that that meets our expectations to get performance tests that are on top of the ones that the VM already implemented? Do we want to take some time to sketch out what that looks like? Right? What are those expectations? What are, or is that something we just simply say we don't have the time to deal with right now?
I think it feels worthwhile to sketch those things out as well, because some of those things could be, action items we take as we go back, right? So it might be worth spending some time on discussing those things.
Just coming to concrete next step. That I think that it's all going to come down to who wants to volunteer to work on it. Right? So some people will be more interested in one versus the other. As long as we define some concrete next steps that we all think make sense, we want to look at those directly. But I think we're trying to map that out.
Okay. So we have a number of things to discuss already. The module developer, abstraction, how we're going to do that. We can talk about that specifically. So the other thing let's talk about tomorrow then is documenting what these expectations Node has of the VM in terms of what the VM is providing to Node, right? And in that can cover a pretty broad range of things, whether it's how do we interface with the pieces, how do we interface with the application, there's a lot of stuff. But it also covers things like what language features do we expect the VM to provide, right? So the generator thing is an example, right? The fact that it's like we only use it once, but it had to be there, right? There's things like that. There's new language features that we're not using at all within Node. Like I think for some of us, the fact that if promises weren't really exposed, I don't think we care too much. But our users would care, but we don't require them from the VM, right? If they're there's certain things that we need though, like visibility. We need to be able to document that kind of stuff. If we don't use it, but we have these requirements of it, it's there, right? And things like that, I think we need to have a clear understanding of. Maybe fairly difficult to come up with that list in a concise way, but I think it's quite good.
What would be a reason to not require any of the basics or like standard? I can understand that we have to document features required on top of the ES6. There are certain features.
Okay,
Promise
so
protection
basically
events.
all ES6 features currently supported in Unmastered.
Well, I think it's interesting to actually define what actually minimal set of what Node needs or Node Core needs, because like if you really want to run into a really constrained setting with like a micro implementation, you want to cut corners in the JavaScript engine, not provide those.
Node Core doesn't need nothing in it.
Right.
We have to protect.
So it's not so much that there are language features that we say we actually don't want, right? And that we wouldn't expose those. It's, exactly, Kurt said is this is the minimal set that we absolutely, need to expect, we need to have, right? And it has to be implemented, right? Anything beyond that, we may want to, users may want to use it, right? It may be there more for convenience, but it's not something that we would certify to say you have to do it in a certain way in order for it to.
So would you expect users then to start doing actions that they know
that's browser hell.
Right.
I left front-end development to get away from that.
But I mean, like, it's kind of, so one concrete example, if you take out ICU, like, all the Unicode regex stuff won't work anymore, so you go back to ASCII regex.
But yeah,
It's kind of, that doesn't mean when I write a Node.js app, essentially it means I have to check what kind of regex fidelity do I get and adopt accordingly.
Yeah, we need to have some that's actually a really good one. We can build Node today without INCL or without ICU there, and get some,
But that's in the build run. Like, you can actually do that. Like, you don't need to test it. Just check the Boolean value of whether it was built in or not.
For your code.
Yeah. Oh yeah,
It has to track and then it has to adapt.
We need to have some minimal standard of what we expect to just work.
I guess what that is like, I'm not going to try and use crypto if I load my library and I check for crypto and it's not there, I'm going to be like, oh hell no, I don't know what to do, right? It's kind of on a bigger feature set. Whereas I'm thinking like minor things like, can I use class? If not, then go ahead and just use full construction. There are different types of features that are being studied.
But is it really a convenient thing? Because what happens on the web is people just pass it through Babel and use ES5 always. Right? I mean, like at that point, basically all communities ES6 is gone.
There's a concrete example with promises where, still today, as far as I know, the vast majority of promise usage is using modules, not filters. So using Bluebird, using Q, rather than raw promises.
Because we can actually do things with those, whereas the native promises are black box. Can't see what happens. There's things like that we have to figure out. Like, if the VM is going to provide this is the requirement we have for that, right? Otherwise, we can't really call it Node because we can't, there's a certain level of functionality we have.
And as a platform, Node's always been built with this, kind of novel point of view of very small core and vibrant user land. Like, go nuts, be creative, and all of that experimentation pushed out into the module ecosystem, and that's been healthy for was done that way based on the experience seeing other standard libraries get written on the time.
For a long time, the kind of the JavaScript language level that was exposed in Node was kind of constant, right? I mean, for a long time, we used similar versions. There was not much ES6.
And then ES6 happened.
And now ES6 happened.
Right.
I cannot tell you how many tickets open of like, can you please set this flag so I can use it all the time? So it's like, yeah.
So ES6 happened, right? And at the same time, we talk about eventually adding multiple different VMs that all have like different ones on the details of ES6. And ES7 will happen, right? And we're right now looking forward to that single rate.
Yeah. No, ES7, yeah.
So it really comes down to, like, right now, the language features in Node are defined 100% by whatever the VA happens. Right? If we put a new version of VA that includes async await, whether it's implemented in a way that we can actually do something intelligent with it in Node core, whether it's debugging and anything else. Users expect us just to go ahead and support it, and then it's like they should be able to use it once because that's what the VA lets do. That's not always practical. I mean, promises is the perfect example of that, because if folks go and use the native promises, there's things you can't do with it, right? And it presents a problem. So we have to be able to at least have some minimum level of requirement there that
in order for us to be able to expose this, in order for us to be able to say that this feature is available in Node, we have to.
You mean like the API supports that feature, or do you mean just like the features available in Node?
I think it means the API, right? Like, I mean, it's typically Microsoft API.
Yeah, that's what I figured. I just want to clarify because I was getting mixed signals on whether you, because like you have no control whether a single way is exposed at all.
But what I'm saying is, if it is going to be exposed at all, then the client we have on it. So if we're going to expose promises, then we need to be able to have it.
Yeah. Okay. Yeah.
Absolutely. So the basic way is there in the DMN. We expect the community. So I'm a module author. Should I be prevented from using it?
Yeah.
So what exactly?
I'm confused.
No, it's like, okay, so Chris Dickinson open PR, right? Those are promises. All hell knows we won't see them. And I think that's basically what we're doing at is what features, what of these features are we supporting in the long run? Like, for example, buffer. We're going to have to make a change to buffer so that we can properly subclass it. You know what I mean? To extend buffer. Because right now, if you do that and you subarray, it returns you a unit array and buffer, right? So those types of things where, okay, it's kind of an edge case, but we need to make sure we properly support class semantics for buffer, right?
But that's still the API part, right? That's not the language part, right? Because taking the other just taking the other example, like async await, perfect example. Chakra supports it today. It's enabled by default in Chakra core. V8 does not have it today, right? From a user land perspective, like how do you want Node to be controlling that?
So it's not so much not making the thing available, it's whose responsibility if it doesn't, right? So right now, the promises is there as part of V8 promise. The fact that we have no visibility into that, users come back and say we have a bug. It's like, you know what? No, we don't. V8 is providing that. It's not something that knows. I'm saying the same something. So promises in V8 are as per the language spec. There's a feature, there's an API feature that we want, which is visibility in the microtask queue. But that's not a bug in promises as defined by the language spec. Right, and it's not a bug in Node either. So it's more of a matter of being able to articulate what is the responsibility of the language, what is the responsibility of Node, and what is the responsibility.
No, but it is in this particular case, it is the responsibility of Node as well, because that whole microtask queue has to be provided by the host. And Node is the host in this case, and
each one, all we do is say run your queue. Okay. All V8 doesn't expose that to us. Yeah.
So there's I mean, I think generally the question is, do we want, like, I can imagine that we end up in a world where we have to somehow figure out, like, everybody involved, all the 300 to sit together and come up with a standard for what is the that microtask. There's kind of some TP39 thing.
Yeah, that's not in the standard, right? Microtask queue standard.
Oh, the standard defines microtask queue, but it doesn't.
Oh, there's just here's some implementation.
Oh, it's just like there's a queue at certain save points, it's execute, which is what happens, right?
Okay.
So I can imagine as a world we just have to sit down and say, okay, yes, there's a space which is not spec that needed spec, and hammer down, like somehow agree on implementation details like this. I can also imagine.
Yeah. And where? Okay, sorry, I just thought of a case where this is actually applicable. Holy crap! In that PR with promises, right? A lot of people are like, hell no, because we cannot support both this API and the support on untimed exception, right? because promises, there is no such thing as an uncaught exception promises, right? And what sucks about that is that you can't get a core file that gives you a proper stack trace back to the location where it's actually through, right? And so they're like, okay, well, let's figure out how to graph. We're going to have to like lunge it so that we can actually export the proper location so we can get the core or whatever, right? It's exactly and I'm sorry if I'm not articulating it correctly. There's a certain amount of behavior that the TC39 is going to define, or here's the microtask to execute, right? You execute it. In order for that to be useful in Node, there's going to be a certain amount of behavior we have to specify, such as, we have this thing called uncaught exception. How does that relate to it?
Well, so, okay, so
there's certain behaviors we have to be
so
able to
either we have to specify this, which kind of awkward because it talks about very specific details of the implementation, or we just sit down and hash this out. Like, this is how it used to work, right? Like, eventually Node needs some changes to the buffer, and then just change the API. I think. And it's kind of, so I just want to draw attention to that. The kind of compatibility list or tests you're just describing requires a lot of implementation detail. I mean, like, already how much time talking about it?
I'm trying to make sure, we're discussing what needs to be done.
Sorry, but I'm just coming up with a Node.js ECMAScript support matrix that we that we defined, and if it's a Node and in version 6, we officially support things not async away, and we say that that's not supported by Node. Your VM may support that, and so what do we do in that case? We shut it down? Do we disable that, or do we just say it's unsupported and go there?
I'd say that. I mean, it's the kind of thing that if it's done in a way that meets a certain set of requirements that we have in Node, then it's something that we can't support, right? But if it's done in a way that we don't have any visibility.
So are you basically getting at, if I'm going through the issue tracker, what measure can I use to determine whether I can close an issue or not, whether it's something that we need to take responsibility for or not? Right? And we're supporting local VMs, and some, like VM X, supports some crazy ES2020 feature. We can go in and say, sorry, that's out of scope, and close that down.
It kind of pushes the problem to the users, right? I mean, like,
what else can we do?
No, but there are a couple of things here that I want to call out. I think number one, right, the same problem exists in browsers today, right? We all fix it. I mean, even as browser implementers, we fix it for the web developers. So, I mean, I don't see a reason why, like, sitting on the same table, we can't solve it for Node. I mean, we do it for all the time. Like, we do it for web developers all the time. Yes, we have completely different implementations, but from a JavaScript user land, in the end, we all behave the same. There are bugs that happen, we fix it. We don't share our implementations, but we fix it. Out here, so that is point one. Let me complete the other point. I think in the morning we started discussing this. There are specific things that are part of the language conformance suite, right? And there are specific things for certain features for which I think, one of the suggestions that I did, it might not be the best, is you also have to think about that conformance suite, that, hey, if there's a feature like promises which has an impact in the language conformance, plus from a host perspective, whenever you enable it, there is this minimal test suite that you have to pass. It might be just one test, it might be 10 tests, that these are the use cases you got to pass. Whichever implementations comes there first, they can define it. Or, we can come up with some criteria, right? You are the first implementation, get us these 10 basic cases. The other implementation which is coming there, right, has to make sure that it complies with it. And that is the best way in which we are making progress kind of lockstep to actually advance the thing. And it's not that everything is going to require additions in both the places. For a majority, they're probably going into the language space. But when there are these specific things that are also tied into the host or the embedder, you just add the very few basic things that need to be validated.
My main concern essentially is like different from what the browsers in Node also have data points. Like when people would start to load random DLLs, I mean, antivirus would start random DLLs into your browser, and we would have to somehow deal with that. It would be a whole different.
That I totally agree, and I think from a native module perspective, that is a conversation we should have, and that is what you were discussing. How do we solve that problem? That we hide from a native module perspective, we hide these things and make them look like the JavaScript perspective. I mean, when I say look like the JavaScript perspective, is as if we are shimming those things either using the API format or the FFI format. I mean, that is one of the things we have to consider in that conversation.
No, okay. Some of what you discussed, I probably did, but from the native API, any API node, I totally agree that we should create APIs that aren't accidentally used stupidly, but it's impossible, and therefore we shouldn't strive to create APIs that cannot be used stupidly, regardless, right? It's like, okay, we're going to make it really hard for you to delete your hard drive, right? But if I go in and do rm spawn rm-rf, slash, I'm hosed anyway, right? I mean, we have a lot more. We are not the browser. We can do anything, and so trying to shield users from being stupid in that way is just impossible.
I think it goes to, so right now, nobody needs to have more visibility and more influence on what's happening in 239. I mean, we need to make sure that we have, close the feedback loop there so that, as these things are being spec'd out, we can put that certified influence into those stuff. But I also think we need to make sure that we have a good feedback loop for the VM developers, that as these new features are coming out, and as they're being implemented, the node use case is being considered as it's being implemented. So thinking about like a promises where, okay, we have this now, we're delivering it, and then after the fact, we're like,
So hold on. So promise keeps coming up, and the thing is, promise. I think the thing we missed was we weren't involved in the DC39 process, so we couldn't raise the concerns. At this point, a lot of the discussion on the promises policy has been about we do not like error problem. Well, it's part of the language, and the way to fix this is going to change the language. So the reason I'm actually concerned about some of this is that I don't want Node.js to be PC39 version 2, right? That's some of the compatibility matrix and tests that we pass language features. I think that just sounds like a solution to me. I think language should be language. Then there's an API level that we want to promise on. I think that's a good place for us to be at. But the specific issue of promises, well, the microclasses issue is a API. Error bubbling, that's language. We may not like it, but it's starting to make.
I mean, I agree, and that's why I was saying the language, let DC39 run with it, and I think from a Node perspective, I'm kind of aligned with you.
It really comes down to having a clear whose responsibility is it.
Yeah.
It's not so much trying to put constraints on what node will actually close or whatever. It's if an issue pops up and it's something and not something that node can do anything about, then basically it's being published.
Yeah, but we could see. Well, we might want to be able to decide when we turn it. Right. So for example, if we think we need to do some extra work on the node side to support one of these new features, promises. You don't necessarily want the new feature to be exposed.
I disagree. I think the JavaScript ecosystem is much bigger than that. Browser users also use the same module that we do. So I don't think we have a business telling people do not use this language feature because
also
or CTC did not like.
Okay. Along with that,
not shutting it down and saying that it's not ready are two different things.
Yes.
So I don't think we're asserting that never, but the fact that we weren't able to wire up the microtask queue into and actually propagate the events in Node properly and deliver the expected behavior to the user, means that we couldn't fully support native promises, even after they were introduced into the VM. And that's, respecting the user's expected behavior around that. And if we can't provide that expected behavior, then we should let the users know that that's.
I think it's completely for promises. That more sounds like a lack of communication. But promises.
Actually, now let's pick up another language feature. We've discussed too much of promises.
A lot of that one, right?
So, but I think I love the point. It's definitely not about shutting off a feature, but it's all about very similar to your current model. Like, hey, this thing is long-term stable. We will maintain it, and we are guaranteeing this thing to work. But says here's the stuff that's edge and experimental. Sure, you can play with it, but don't be, it's not 100% guaranteed. If we make changes, it might evolve and break.
The other side too is differences in the way that the different VMs implement.
Yeah.
Right. So if there are inconsistencies in Docker and VA and the way a particular language is implemented, and that causes a problem in the ecosystem, right? So somebody writes a module that assumes a particular behavior that's not
right? What happened done is that this is the test 262 test that says this is how expected.
Yep. And one of the two will fix it.
Well,
maybe.
Yeah.
It still comes back the ecosystem views that and says, okay, well, this is Node. I expect it to behave like this, right? Regardless of what VM is in the right? So at some point we have to be able to say, okay, yeah, this is Node. We expect this certain standard of behavior. Anything outside that realm, we push to the VMs and say, okay, that's up to the responsibility to go fix to make sure that this doesn't happen.
Sorry, go ahead.
It might be like there's the safe mode. Like the default mode is we think all these features are ready. We've got all the stuff we want to support that. So by default it's turned on. But if you want to use the rest, we're not going to prevent you from actually turn on a flag that says, I know I'm going to experiment. So when they raise the issue, say, sorry, if you're using those experimental features, you have to talk to the browser people.
I think it's sweeping too much through things that there are, and I actually think it's totally fine for Node module authors to use promises. There's nothing wrong with it. Node code shouldn't use them, perhaps, but if people in the module solution want to use them, it's fine. I think it's their choice to use it. It's supported by the language and spec compliant. That's all there. That's guaranteed. Nothing more, nothing less. So for other features, if it's spec compliant, and for us to turn it off by default is again going to default.
Yeah, there's nothing you would ever think to turn off.
If it's a bug or security vulnerability.
But there's
especially with the buffers. Again, sorry, promises and the whole core DOM. There are companies that basically they have outlawed promises because you cannot get core dumps properly, and you can't get certain debugging properly using promises. So they just basically said, hey, everyone, you're not allowed to use promises in any of your libraries that we run on our production.
That's not a decision that Node should be making.
Yeah, exactly.
Right, but again, just to add to that point, like whether everything will be switched off, I think all of us now, I'm just speaking from a VM implementation or a browser implementer perspective. We don't get any feature out and just throw it out saying it's on by default. We have it under experimental flag. We go see how much of the web we are breaking. We go look at telemetry data. We go look at user data, and then we turn it on. It's very similar for Node as well. It's not that, hey, we just tested it in the browser, works well, here you go, Node users. It might be a different use case. No, it might be a different use case in actual. Promises, maybe that was the example you guys are talking about. I'm sorry, I don't know about it, but I'm just saying, like, in the browser land, we do test that stuff. We do test that stuff. We go and validate stuff. Like, we all have things like we go ship something in the canary bits. We, look at what feedback we are getting. We then go, okay, the web looks okay, let's go enable it.
From what I can see, the browser vendors have a far more advanced infrastructure to do this kind of testing, right? Like Node Core has no way.
Again,
the outcome of this is just building out.
Yes, exactly.
Having the test suite and aligning to the existing surface area of 262, and then having a little.
We also have a test suite, like before we even put this in experimental, we pass all the tests, right? Great. Like what happens is if you then enable it, and the world runs down.
I think all I was saying is all I was trying to say here is like it's absolutely okay to say that a feature is still experimental and this thing is now stable and enabled by default. I mean, coming from that perspective, I'm just thinking like if if the CTC says this to me, if I'm a normal user, that seems absolutely normal to me. But if the CTC says like, hey, you just cannot use it, that sounds wrong. Right? And that's why that's the conversation, that it's not about, it's just a dial about, hey, this thing is tested, ready, production ready, and this thing we're still, and that will actually not even come in the, way of people actually enabling features.
My concern, and I think based on what I was reading the thread, my concern is not so much, kind of the new feature, and whether one VM supports that feature versus not. I mean, we can deal with those. It's the inconsistency, the potential inconsistencies in how those things are implemented.
Yep.
Right, and whose problem that is. Right. That we don't want a situation where the same feature is implemented in two different ways by two different VMs that both call themselves nodes. Two different implementers both call themselves nodes. Especially if they're the same version, like Node and C, right? It should work consistently across things. And if it's not inconsistently, then whose problem is that?
Well, what do you propose? I think I finally heard and see what you're saying. Okay. All right. So there is a spec, right? And the spec has more things outlined than has been implemented, right? So where do we draw the line of what node will properly support? We can't say, oh, we properly support the entire spec because no VM properly supports the entire spec. So we have to choose some subset of the spec that Node says will properly support. And if a VM that sits under Node chooses to implement more than that, good for them. But a VM that chooses to, like a VM under Node, must support at least this much spec and must support all the compliance tests for that much of the spec.
James, is that what you're, because what I was understanding is when you said implement, you were still referring to the API piece rather than the language piece. I think that is what I am confused about still. Because when you said, right, how it is implemented, it is basically the API that is being exposed. Is that the conversation, or is the language support the conversation?
I'm an API contact.
Yeah.
So yeah. I would say more APIs.
Yes.
Like if it's a consistent behavior, when I'm invoking this API, right? That
yep.
There may be slight differences.
Yep.
Right?
Yep.
The memory model
yep.
may be different, whatever.
Yep.
When I call that API, what I predict is going to
yep.
happen in a consistent way.
Yep. And I'll take a very simple example. We were going through the JSRT API, JS strict equals. That is the API we are talking about here, right? From a language perspective, whatever triple equal to does is not the concern. That is, again, interoperable between VMs from a language specification perspective. I think what you all are, concerned about is like, if you have this kind of an API which is JS strict equals that we are exposing, take some other flags, but return something else for the native user land, right? That is the API contract that you are worried about. And for
do we need to think about APIs at that level, or what we actually do with the APIs? Like, let's say stack traces. So Node hosts those VMs. So we started our form of stack traces, and we make callback adds a prologue and an epilogue to every callback and things like that. Is it that we want to expose that? In which case, like, let's say V8 does in the same way Node does. Do we need to specify the additional layer that Node adds to the language? Like, our stack traces look like this. We add a prologue and an epilogue to callbacks, and then if the VM owners want to implement that in their own way, then they can. It has to come out the same way that Node comes out now. But how it's implemented internally is an implementation detail. We can continue to work with V8 and just use whatever APIs they give us. Chakra can do whatever they want to do.
So I think that the question is like, if this doesn't work out, what problem is it? That's what
yeah,
you're saying.
yeah, it really is. The problem is that Node needs to be able to expect a certain behavior, right? They call a trigger like strict people. We have to be able to say we expect it to act this way, right? If there is a variance between VM implementations of that, then that's the VM problem, right? And if we want to be able to call this node with this VM, then it has to implement that behavior in the way Node expects it.
So the
Otherwise, we can't call it Node.
So the difference is in the language that even the TC39 will have an issue.
No, it's the API contract surface, so it will not happen in TC39. TC39 will only worry about the semantics and the behavior of triple equal to. They will never say that you are looking into, hey, in JSRT land you're calling it JS strict equals, in the V8 API land they're calling it something else. They will not look at that. I think one of the places, I'm just going to suggest this, one of the places, given that we've been discussing and debating it for so long, is probably to look at the current set and, as an experiment while Curtis was out, kind of commit something from his team's perspective that came back, man. I mean, of course, coming new in here, right? I mean, we can definitely, from Chopper's perspective, say that, hey, we will be making sure that we adhere to some of the things that V8 has been doing in those areas to make sure that we, start complying. I mean, as we are coming next into the game. But the only problem is we all have to think about what about the, next thing after Chakra that comes in. How do we make this a standard that, hey, if you're coming in, this is how you will have to play the game. It's not about disrupting what is existing. It's not about changing them. I think we can commit to align at least in a few areas where, hey, there's already an expected behavior that V8 is showing. But whatever new is coming, there's probably, a way in which we either work through an API working group or a, specific working group. Hey, there's this new feature. We both are working on it together. We work on those features together in TC39. I see no reason why it would be too hard.
Right.
Well, I guess what comes back again is the promise thing, which already without Chakra doesn't work out.
And for example, the promise queue, I think it would be great. And anyways, whether there's multiple VMs or not, that there is specification of what you actually expect to work, how you expect to work. Definitely, TC39 does not specify every single thing that it needs to do, and there might be specific things that Node kind of wanted to work.
Oh, yeah, okay,
and so if you actually document that, I think that would be great for the user anyways.
But Microsoft is specified, right? It's specified in HTML. But it is
specified. Yeah, see, so when it is the HTML specification, you're absolutely right. It's the HTML specification which is implemented by the browsers. And what Curtis is saying is, if there is something similar, so it is the host that is specifying it. If Node can also specify stuff that is in HTML, it will be great for the users. It will be great for the implementer.
I think microtask queue in particular, by the way, is actually the ECMAScript standard. Well, I mean, not microtask queue, but like the microtask behavior.
The way it's implemented doesn't even matter that much. If we specify, look, we need to
use this
kind of information, we need to do these kinds of things. Then we say, look, we say, look, if you want to implement promises or whatever, we're going to need to get, this is what our spec says Node is going to do. To give traces in this way. And then as long as you allow us to do that, then we're fine.
Node does have expected behavior in terms of when microtest process, because we start with our next state queue internally, and then we process the microtest queue, right? And we bounce back and forth for an exception and exception. So, and that is expected and completely, I believe, completely independent from any spec or anything, right? But any VM coming in, we definitely have to say, like, hey, you have to give us the ability to run the microtest queue. You can't just run it whenever you feel like it, right?
So building on that, something that Fedor brought up earlier was post-mortem debugging and how we can keep that similar between the different VMs, and I think that's kind of very much on a similar plane.
Yeah, I think the point is, if we're definitely going to officially supporting multiple VMs in Node, we have to make sure that VM implementers are doing things assistance by talking to each other on that, and also we're providing, this is us provide the expected, what we expect of the of that API, so that can be implemented. But we need to make sure that there's
But I mean, there are some things like the GDB-JIT build configuration flag that I personally love, but I don't think we can reasonably expect other VMs to implement that, right? You know what I'm talking about? It's basically like if you jump into Node, the GDB or LDB with GDB-JIT, and have that GDB configure when it was built, that means I can walk through the native and the JavaScript code through GDB. But also, I really don't think we can reasonably expect that from every VM, can we?
We have similar things.
I don't think it's a feature that any user actually uses. I think there's 2 people or 3 people on the CDC probably that have ever used it. So,
am I one of those?
So I guess it is awesome. I think that what we're talking about, like, I mean, the language behavior exposed to JavaScript is defined in 39. I mean, that's kind of like, we have this dependency and that's what's committed to make this work and going forward. But what you're talking about is C++ API, and that is not specific at all. So it's essentially, like you said, you could call it strict equals, but actually what it does, it deletes the random number. And it's perfectly fine. And this is an issue, right? I mean, it is a certain issue if you have a single VM, you can kind of hash it out and not call it a function if you don't want to delete stuff. But at the point where you have multiple VMs, you either have like more than number of VMs, big problem, or you kind of sit down and specify behavior. And so from my point of view, like, so what we actually try to move to the V8 API is that the plus API, at least like the core part of it, mirrors the behavior of the JavaScript exposed API. Like, you kind of, like, if you have behavior on TC39 specified, we're more than happy to add it immediately to the plus API and can guarantee that this behavior will stay because we have to support it anyways as it's exposed to JavaScript.
But only like, I mean, that's about semantics. Like, okay, I want to do like a strict comparison. That is something that's implemented in the spec, but like, what you call the function, how you pass the arguments, that kind of stuff is still something we would need to agree on together.
Right, but like, I mean, yeah, you could lock this down. Basically have like the Node VM API, either you implement that one. But it's pretty extreme, right? As opposed to saying like you just expect that certain behavior is available to the C++ API.
I mean, that's a good starting point. I agree.
And then like what I hear from the story, or like GDB-JIT is kind of like an extreme example. So we have certain behavior that Node needs that is not 39 exposed to behavior. At least 39 will never talk about setting up the but it's a certain kind of API that you need for Node, and like what happens there? Right? Basically, do you need only 39?
Okay, so like, one API that V8 was kind enough to implement after much begging was the ability to grab the contents of an array buffer from the native side without making it external, or basically right? Yes. It was there, and then it was removed. And then we had to say and re-add it, but it made things so much easier. And yeah, like V8 has done some stuff for us that has made life a lot easier. That was definitely like outside of spec or anything. And I guess are those, going back to you, like are those the same types of things we're saying like, hey, the new VM will also have to be okay implementing?
That's what I'm saying. We need to get to the point where we need to be able to answer that question. Right. Is there some minimal API surface or expectations of the API that have to be implemented by the VM in order for us to be able to say that Node with that VM is actually Node.
But I would argue that I mean the use case in particular, like the array buffer thing, it like is valid. Like it's something we want to be sort of in communication to the VM maintainers about. But I don't think we're in the position where we can demand that engines implement a particular feature. Like those things usually they should and they will sort of be part of a conversation, literally, like where we get together with the VA people, and the VA people are like, well, we can do this, and then like maybe some other VM people are like, that's really complicated because we want to move that thing around all the time, and it's important for performance, and so that's so like and we also don't. I mean, we should not be so arrogant as node maintainers that we know exactly all the considerations that go into VM design.
As far as we have a desire to create an abstract API, right? At that point, we have to say like, yeah, array buffer. V8 has given us an API that allows us to hands us back the pointer without forcing us to take other measures, right? So for an internal abstraction, I would expect that is there, or else we are going to suffer serious overhead.
And we run a test to test it.
Yeah, and so that test would be the enforcement against VMs being able to implement that abstraction.
I think like one practical thing I would take out of this discussion is that there's certain behavior that is expected of the C++ API that is not what you can directly derive from similar behavior from JavaScript API that you need from the VM. And I think the key part really is that, and this hasn't happened for some features in the past, trying to get better with, but you need to build a common understanding what this exact behavior is. I don't think it makes sense for to try to specify like this is the API we need. Because as you said, there might be considerations from the VM point of view which you just didn't take into account. What I think is important is to identify such issues, like problems, for example, and sit together and figure out what is the actual behavior we're trying to achieve, and what is the API we can get there.
And yeah, like what is the high level problem that Node is dealing with, where we need support from the VM implementer? Like there might be a very different way to go about it, and like if people agree on that. But if you look at like how the TC39 operates, like it's certainly not that the TC39 like dictates. I mean, maybe like that's what I don't know if you guys feel like it does, but it's not the intention of the TC39 to dictate behavior, right? Like in a way, it's just like a group of like VM implementers getting together and try if they can sort of figure out something that works for everyone. And I think that's like, I mean, that's also what we should be doing, like really.
Now, if there are certain things like we have a requirement, we have to be able to see the microtask visibility. It's a requirement. We're not specifying how that works, right? It's just that we have to have that visibility.
Yeah, but we could even go a little bit further up. Like the problem we're trying to solve is we need to be able to pass forward some context. Like at some point a microtask gets scheduled. Context needs to be captured. It needs to be restored when it actually runs. And ideally, we'd be able to, if in the microtask callback an exception is thrown, we want to catch it. That might be. I'm not sure if that's exactly the thing, but like I think it's something around us. Like, how can we achieve this? And I look around the room and like what.
And if we do support multiple VMs, you don't want to have to do that two different ways depending on the VM.
Yeah, exactly.
And more importantly, that whatever functionality we expose to the user, whether it's through JavaScript or through the native API, that the user is not going to be surprised because of some difference in the way that particular feature is implemented, right? That there is some consistent behavior that they don't have to know what the underlying VM is. That it's just going to work in a consistent way. Now, there may be some things we have to do in the native side and the Node side to smooth over some of those differences. But what is exposed to the user is consistent.
So I would even argue that it doesn't really. So in WebKit back in the days, we also had two VMs, and they definitely didn't have a similar looking API service. But it's kind of possible to track away.
How did you do that?
Oh, like as I tried to argue we should do it in Node, we had this one directory, we still have it, where there are wrapper types that basically anything that would come from the VM engine gets the C++ class. And only interact with the C++ interface. And
The
then
script
the IDL
things that you
like,
said
yeah,
before?
script values, script promise, like all these things. And then you have the IDL description of what is expected behavior going between JavaScript and C++ and have custom generators.
A good deal of what I wanted to do tomorrow is to figure out, okay, I mean, a lot of these, we talked about a lot of these ideas. Let's see what it would take to actually make this happen in Node, right? So part of the discussion would be, okay, that sounds great. We're not there. We're not there currently. So what would actually need to change in Node for us to get that mechanism in place? I think maybe understanding more of how it works in Chrome. Just the technical details of how it works would probably go a long way to helping to understand what that would actually be.
People said, we don't want end users to have to know what they're running with it. That to me extends to the JavaScript side. Like if we have a state where one is implementing some features, another one is implementing different features. If I can easily write code that only runs in one versus the other because of that, that's something we want to try and help the user at least know that they're doing it. Right? Like, is there a way so that they can know, I just wrote my app and actually I only use stuff which is safe and works everything, versus I just wrote my app and I happen to use some features that are available in V8, but as soon as I go and try and run it on some other one, it's going to fall over.
Well, okay, so
You mean like dash warn on two fancy features? Is like.
Yeah, just how do they know what it is they
I mean,
made
like how we solved this in browser websites, they essentially can render you stuff, like they give you screenshots of how it looks in the different codes, different browsers.
Well,
like,
since that that would depend on language features, wouldn't that be largely possible to do through static analysis? Like, oh, you're using a class keyword that doesn't exist in this VM.
Static analysis in JavaScript is pretty hard.
You can just, I mean, I think for most of these features, you can just try to parse a script. If it parses, it probably works. There might be some area, there might be like, is the global promise object available? I think that's not right. There might be some cases where that.
The user has to have both. It's a little
Even
more than that.
if you have like one VM, different versions.
Probably even
if you run it, like, it sounds nice to have, but it also sounds difficult compared to just testing it all.
It's just a little more so than that. It can even come down to, I'm getting a listing of this is one that's crossing my head. One of the VMs, for whatever reason, one of the implementations, for whatever reason, returns that as binary string, and the other one returns it as UTF-8. The procedural differences. When I call this API, right, the inputs and outputs, I need to be able to expect those, in a consistent way, right? So that it doesn't come as a surprise to some subtle bug that's because it's implemented on Microsoft, it's implemented as sort of the result of the fact is slightly different than what it would be on.
Those are the subtle ones. I think we'll just have it's just not implemented at all, right? Like it's not even subtle, but as the developer, I won't necessarily know that unless I say, okay, now I'm going to test on every single one that's going to run or
Travis CI from multiple VMs.
Like
it almost sounds like we need a project like that. Like, hey, now we have a test environment for SVA.
But you say, can I use, right? For nodes. I mean, that would personally
yeah.
I think we want to avoid sort of the pathological cases, but obviously, like as one engine implements new features a little bit faster as the other, I think that's kind of the good problem to have category. Like it's like either you don't have a feature or you maybe have it.
I guess on the server side, it may not matter as much, but if I'm a developer, I guess for modules it does, right? Like if I'm running my own app, it doesn't matter because I'll just test on the one I'm doing. But if I'm pulling in modules, you don't want people writing a module.
That's true.
Primarily used version boundaries.
But I guess
it's probably slightly different too, because so we do have this test 262, which 14,000 tests that technically measures performance, but on the browser side, it's sort of like we implement only as much as we need to until websites start complaining. Like we don't have 100% performance.
Right. Okay.
So what bar do you set between the minimum performance you need to be an official endpoint? If it's 100, like and
right,
VPAs are not going to be work. So there's always going to be these little edge cases. As soon as you have two engines, you will set yourself up for modules that do work in one but not the other. I think it is a Pandora's box, but
I prefer though to like not be too strict. I mean, like yes, you want to be aware of the risks, but like I mean, like for example, like the GDB JIT example. I mean, I know, like, I take it for granted that you love that feature, but let's say that the Chakra people don't care, but what they implement is a profiler that you can leave always on your production server. I mean, I go for Chakra in that case, right? And so, like, giving people a little bit of choice is actually helpful. And like,
I think those would be easier cases. It's not, I wrote my code and it didn't work. It's like, my code's running, but maybe I debug in a different way.
Yeah. Or we could even take the approach, like, if people can show us, like, we could maybe even disable experimental features by default and like standardize on the flags that you pass to Node to enable them, for example.
Right, like that's the kind of thing. So now I know that I'm more likely to be using the ones that are going to work everywhere, and I can turn off the seatbelt.
Well, since how is that? Like, even though major versions allow breaking changes, I would doubt we would introduce regression between major changes. Like, oh, you could use this keyword. Oh, sorry, it's gone now. From one major to another. So it's like, in my mind, the minimal set of those 14,000 tests that we say have to be passed or whatever it's passing right now. Because that's what's currently supported by Node, right? The fixes, right? We have this is our baseline.
Yeah. So the other thing to consider is that if I write a module and I basically don't work with a popular thing that people want to use, you have no idea how fast people are going to get a issue against my module. So,
and there's a certain level of like, things you could do in the ecosystem as well. Like, what if npmjs.org lists what features it expects of that kind of stuff, or it refuses to install versions that require on ECMAScript features that are not implemented by your current runtime. Like, it doesn't necessarily all have to be done in Node itself.
For the most part, module developers are going to be motivated to implement the module in a way to work with a lot of number of these, faults.
There are so many models, except for major enterprise ones like maybe Express and Happy, ones like that. The majority of modules are all ones that are using the greatest features on master that will not work on core.
Are those ones, where do those sit in the most strongly used ones?
Well, that's what I'm going by percentage. I don't know what the profiles are.
So there's going to be a long tail of modules that, where the developers are primarily focused on doing something cool. Right. And they're going to be the ones that are using are going to be much more.
What I'm saying is that the long tail is inversely proportional. So like, how often it's used is going to be stacked up over here. So the least used is going to be stacked up over here. The most used is going to be a long tail of not using newer features. Does that make sense?
Well, no, actually, I don't agree. I think that the most popular modules are actually reasonably conservative about these things, and it is mostly like, people throw something together for their own like itch, and then they might use generators, whatever.
I totally got that across.
Okay, but I mean, like, it's yeah, I mean, it's a valid concern, but I fail to be actually very concerned about it somehow. Convince me more.
The modules that you depend on the most are going to be more conservative, are going to take a least common be some pressure to bring these new features in, but if those, like Ticket Express as an example, I know Doug has absolutely no interest whatsoever in changing it, re-architecting it to use promises and the latest things because
might be different next week.
0.10 and 0.12.
Sorry.
At least for the time being. So it's yes, there's a possibility of there being this difference, engines or beams per module. Based on what features are available, I think that's far less of a concern than modules having to be written on common language features that are just implemented differently, right? Or have slight quirks between how they're implemented, so that you have to have some code that says if you're on Windows and Chakra, run this logic versus
right. People doing the right thing already don't get the right thing.
Right.
Versus people who we're not worried that the people that matter will do the right thing or the wrong thing accidentally. There's no point trying to help people avoid that.
So, it's a language feature implementation difference. And that's really a bug, we should fix it, right? So if it's an C++ API somehow difference thing, I would hope that we get to a point that this stable API can basically level this out in almost all cases. I just had somewhat related idea when you mentioned 0.10, 0.12. Do we intend to define the API and backport it so that module authors that actually want to support the whole range can also move to the new API? Or
that has to support at least version 4 going forward. 0.10 and 0.12 no longer supported as of the end of this year.
I'm not even sure it has to support 0.4. Like if we only did it for the next LTS, I think we'd be good. And if it's really easy, if someone feels like it, if they can backport it.
It's not a bad test. Like if you can't backport it, that says we've got something wrong in the API, right? Because the whole point is that when there's new versions of the 8, you don't have to change it. If you're telling me I have to change it to go back 1. Like if we come up with one and this API works great with 4, but I look at it and say, well, I'd like to backport it to 0.12, but I can't because the 8 works in a different way, and I haven't wrapped it up with my API that I chose isn't generic enough. Then we're starting at a place that's probably not good because who says that 6 won't go back to doing what 12 did, right?
Yeah. So what Michael is saying is it's a strong if you can't adapt another implementation to your API, that is a strong suggestion that your API isn't so great. And I think it's kind of happens with NAN, right? Like the fact that NAN has to change all the time if V8 makes a small change suggests that NAN is not a very good abstraction over what.
If we take a third VM, just not even worry about going back. We take a third VM into the situation and realize that crap, we got to change our API abstraction again, then we kind of fail. Right?
Yeah.
So we need to be reasonably certain that API abstraction, that API abstraction is reasonably complete.
So I don't know if we want to go back, but we should be able to easily if we want to.
So 2 points there. So one is, in some cases, there will be a spec compliance bug that existed in older versions and got fixed. Well, so those things will break. The other thing is, I wouldn't be as strong to say such a strong thing as if it doesn't port to a third VM, it's not correct because the VM has to have a feature set that has to be able. So if they cannot do anything with weak references, well, we cannot use it. So that might be a bit too strong.
Well, I think that we should be able to find one that at least supports some minimal things. Otherwise, why are we trying, right? If there's only 2 VM that is capable of doing this.
The node module API is not going to be that long. Like if they really need it, the answer is yes, okay, but then what happens to the VM that can't provide? Well, if they really need it, they should probably add it, right?
Or to put it differently, like duct tape may not have the worst, but like JSC or Fireman.
You know, I don't know, like a reasonably. So I don't think it's a failure to say just because duct tape didn't work because weak references didn't work that the API is wrong, right?
No, maybe they should add it though. Like,
sure,
it should either be one of the two cases, like we feel they should add something what they thought, or it doesn't.
I mean, like, I think the minimal, the API set that we come up with basically documents the requirements.
Right.
And basically, if really there is a capability missing from a VM, it cannot be put into node unless they actually provide those features. But if it already has the feature set, it should be easily able to, or easier to port into and plug into the new API.
Creates a version of Node with this VM that doesn't quite meet everything, right? Then if there is a problem, if somebody's using that, we know where the problem was. It's very clear that, okay, you know, it doesn't work because the VM didn't meet all the requirements that Node had. You still might call it Node on this particular platform, but it's not fully compliant with what Node requires, right? And we can start classifying whose problem that is versus it's not something that we support in Node because you're not doing what you're supposed to do. Right.
I think your point was good in that if they already had the functionality, but we have to change our API so that it works with that, then the APIs perhaps default. If they just didn't have it, then no, the API says you should have it. So it's whether there's something already there, but you have to tweak things so that it works with, because they've got a different implementation.
But the spec compliance comment, that's not hypothetical. That actually happened. In Node 12, when they cut the 3.19 branch, the tagging system forward, so we actually got a 3.20 branch on accident, which has experimental features, so we had to that. But we're probably 3.19, and so like we lost the feature, and we had to go through and actually like go into 3.20, find the feature that had been removed because of that experimental feature that was removed, and then go back for it, put it on top of it.
But in this case, hopefully we never expose that on our much smaller constrained API.
I'm talking about like language feature JavaScript.
Right, but like, I mean,
But
yeah,
our
especially
API
about
can change for every one of them.
And backporting does not necessarily mean that you have to backport the engine itself.
No, I'm just saying that the fact that a feature was removed in a future version wasn't hypothetical in Node's history. It has happened.
It happens all the time.
No, it doesn't. No, it's only happened once that it was actually lost.
Well, I mean, only ones that we noticed it because it affected us.
So put another way, there's second platform that V8 fixes. So we're not backporting. Like, we're not backporting everything that V8 changes back to the TS branch, or non-active. So
I mean, the idea of the TS branch. That's why I knew ES6 and 7.
Yeah, that should not happen.
It really comes down, like I said, it's not so much that you want to block anything or anything else. It more comes down to whose responsibility is this problem, right? If somebody takes, let's not even do the back over VA or whatever. If somebody comes up with a new version, a new VM, they adapt it to this, but they have a spec compliance issue in that VM, right? Yeah. They put it toward APIs. Somebody uses Node on that VM, and they realize, oh, this isn't the way it's supposed to work, right? That's not a bug in Node. That is a bug in that VM, right? And that's the responsibility. That's exactly how we handle it today. We just need to be able to say that if there are variances in how these a certain class of features are implemented from one VM to the other, that is a VM problem, and we need to make sure that those VMs are fixing things so they are consistent, where anyone who's using knows it works.
So as a JavaScript, right? There's those 14,000. You say 14,000 seriously?
Oh, yeah. They're constantly adding.
That is insane. All right. So the game comes in, right? And I assume that we have gone through all 14,000 and picked one that we say will it'll be supported.
That's right.
But you're right.
Just randomly.
Yeah. And if VM fails one of those tests, that's easy. Right? That's super easy to point to. Now, if there's a discrepancy between how language features work between two VMs that isn't spec, I would say what we do is go to, I don't know who the hell to, but we go to someone and say, hey, there's a discrepancy between VMs. Let's add one more to that 14,000 tabs. Submit that, and then say, hey, VMs, you got to fix this. Like, basically, don't go to VMs specifically. You say, okay, let's make sure test that.
It's actually much easier because like when it comes down to language level features, like the responsible party is TC39 and they will discuss this. Like it's kind of like what they're for. And last time I was there, like a couple of these things were actually discussed in behavior where I mean you don't even want to know the gory details. It's like so edge casey and fringy, but there were a couple of things that were clearly different between engines. But I think what's more important is indeed like being able that we, that is kind of obvious and that we all agree, like who's at fault. I mean, and that's not always been like that in the past. Like, the ability for us to attach, a binary buffer on the heap to a JavaScript object, like from the node perspective, that was absolutely necessary to achieve reasonable performance, and from the JavaScript V8 perspective was that. This was a stupid feature that we should never have rely on in the first place, and like that is, that kind of discrepancy we kind of want to avoid, which we can if we agree on like what sort of a minimal interface is that the VM API should offer to Node.js.
As we introduce multiple VMs, especially if we want to get to a situation where Node Core is, providing support for these. Say at some point in the future we actually want to ship a Node the chocolate binary, on the website. Users are going to have support for that, right? We don't want to get in a situation where we are forced to support these VM, these discrepancies among the VMs, when it's not something that we really have any control over, right? And we don't want to, in a situation where okay, we expect this, V8 says, well, that's stupid, we're going to do it a different way, but Chakra is like, oh, that's fine.
Right. I mean, realistically, you don't have more control over VMs than we have control over how we use us, right? I mean, like what I can do is I can send you a pull request, but that's also true the other way around.
Well, I mean, I think
it's not about control, right? It's not about anyone controlling what the other one's doing. So I'm making sure that there is a clear line of responsibility for who's responsible for pieces, and making sure that there's clear communication and collaboration going on. That okay, if this particular feature is going to be implemented, it needs to be implemented in right, and if we have to, and notice I have to be able to say, okay, well, we have this set of requirements for the simplification. Also, it's not just from from the browser perspective. We thought it should be implemented from Node as well, right? So that feeds into the
right. So it seems like I kind of feel like what we should do. First, we have to identify a subset of those tests that we accept, and the easiest way would be to run Node except right now it's a task that people expect. And then in future, make sure VMs that are attaching to the task set. If a bug comes up and a test doesn't pass, all testing paths we determine it. We go to the TC39 and tell them, hey, you figure it out, write a test for us.
What do you do about the cases where the user expects failure to happen? So if you run all the tests right now, a bunch will pass, and the users expect this, a bunch will fail, and the users will expect this. Now we fix this. Oh hell!
Right, they're saying.
Yeah.
And there are examples like that, but.
There's stuff we purposely don't pass.
But I mean, that's mostly like web compat, sloppy mode, blah blah blah. Yep. Yes, there are. I can. Yeah. We're not going to talk about it.
So my question is that it should be fairly easy. Like, I think there are three things. Like, one is the API you need to expose to native modules. And I think it should be very easy to hammer this down. Like a lot of the hairy details are not in this API just because we don't want the module to mess with the end state. We want the module to more or less rely on ECMAScript defined object. And so like getting this right first, I think will get us a long way in figuring out how we can ensure this API. I mean, I guess when we define this API, it also comes a set of unit tests or something that says this is how you're supposed to use it, not this is how we expect it to work. With scope tests, like Chakra wants to implement it, they should have a way to tell that it's actually doing the expected thing. Right. But I would start small in the sense of not trying to make this the VM API, but making this API project close native module offers. I think that's already a really big task, and it's going to go a long way. Like what you described about the test 262 thing, trying to figure out which of those we want to parse or which of those we want to fail for whatever reason. Sounds also like a useful thing to do right now. And like the second thing is that there appear to be still a bunch of concrete issues with promises and so on. And it sounds like we just need a bit better communication. It doesn't sound like something we could solve. Yeah. Cool. So
Agreed.
Please reach out. Or maybe and then the third thing is like once we actually learn from the native API or ABI abstraction, and we know what kind of resources, what kind of velocity we can expect that people actually move over to this, that we can actually implement this API. We can look at the bigger picture, like how do we still want to have VM abstraction? Like if yes, how would VM abstraction go? Like how we can solve problems like when the promise thing comes up in a multi-VM. It sounds a bit premature, like trying to figure out the exact process and committees and standards for solving these problems that will realistically only come at the very end. When we have all of them.
Well, I think, I don't know, it's actually maybe, what time is it? It's almost 4:30. Maybe it is an idea to think a little bit about what we're going to do tomorrow.
Yeah, that's,
and ideally, like, you know, it was really good talking to you, but like maybe not like an open brainstorm the all day, but like a little bit more concrete output.
Much more concrete.
Yeah, why don't we do a quick stretch, then come back and let's forget the agenda tomorrow. So let's take maybe a quick 5-minute break.
I got you for 1 second. Does it look good for you? I'm just about to cut. Oh, ew. It's all good.
I do not know even what to look at.
Yeah, don't worry about it. We'll talk to Jens about it.
I see an API change in here. Why is it like 6028? Notable changes.
Yeah, exactly.
Is that an API change?
No, it was Brian's path changes that he did before introduced a whole bunch of regressions.
Oh, okay. So it's a bug fix.
Yeah.
Okay.
Let's go, man.
Oh, sorry.
Yeah.
Hey, James.
Yeah. That's what well, originally defined, but there's not a prototype of the receiver.
Has anyone else expressed?
I don't know.
I actually didn't know
Right, so we started the receiver. As far as
I don't might have. I never read it to know whether it was my fault or not.
Yeah. So when we look after something on the object is done, look at the rate, and we start with the receiver. Initially, get root is like the receiver, it's just the receiver, and then so initially receives like this and folders the same.
Yeah, you can guess how much.
Somewhere.
Yeah, I have that
Well, okay, so one was the actual like.
So the thing is that the prototype
So this is data.
Right. Okay. So you can your prototype basically sort of gets a detour. Okay, I'll look into it. I mean, I don't really care, but like I was.
So like, same problem. Like you take a random getter
Well, I mean, I think you don't want to crash. Like, you make the assumption that in your internal swap number 0, there's a pointer to like object ID. It's just like number Fabric.
This thing about
Hopefully, I wonder if everybody coming up with a bigger idea. Somebody talking about it's like this.
There are more
back in back, right? So they got they're all like they were automatic.
So that's what I think we can identify.
Yeah, see how far are you?
I think we should
I don't know in traffic how much it's going to be. I mean, in the morning there was very less traffic, so it was still okay.
I think, some education stuff, like,
For
we have to
south,
try, I think, it's interesting, but I'm not sure I understand. I don't think.
Dan, good. We should. I will make sure that tomorrow we take a break after every 2 hours at most. Not at least.
So I've been over there poking at test 2, and is there any expectation with Physics 2 that it maintains, a spec definition of, 2015?
Yes, there is.
Okay.
So there are
the GitHub repo. It's like
so the test262 repo as it exists now has, or when I looked at it about 2 months back, it had around 26,524 tests. Okay, I was just looking up the number. To be precise.
A lot of different generators. You see my name in it?
Oh, just some of the I was looking for, how to run it.
Right. Out of those tests, I think about 14,000 odd are pure ES5. And another like 10-12,000 are now course related to ES6. Yeah, there's currently no easy way that you can bifurcate like these are the ES5 tests versus there are the ES6 tests. So I would probably need to go back and ask the right people if there is, because I remember that's been one of the contention points we've been discussing. Like you should be easily able to say this. But that said, I think the VA team has been doing an amazing job Boku, in terms of adding more and Boku. They've been working with Boku to add consistent number of tests for each feature that comes in. So sorry, say your question again. I just
they were saying that at TC39, anything has to have tests.
Yeah, so that's like starting with ES 2016. It was not part of ES 2016.
So that's the new.
So starting with ES 2016. A feature makes to stage 4. Stage 4 is basically, hey, you're ready for ratification. It needs two things. One, it has to be implemented by 2 VMs at the minimum. And there is an active debate going on right now, which probably didn't happen in this TC39, but we are going to bring it up in the next TC39 as an agenda item. Is it's unclear whether it's experimental or they want us to ship those features. So the current bar is you have to ship those features. It seems like a little iffy because you're saying, hey, you ship those features, and then if you change them, you're going to break the web. Because if somebody has already taken a dependency, you're going to break the web. As a user. Ship is like it should be shipping in a valid browser, not behind a flag. So, like, if you think about, it should not be behind a flag. Shipping in a, being available in a shipping browser, not behind a flag. That's the definition. And that's a little iffy. That's one of the things we need to close on at TC39 because that is not very clear. So that's one part of getting from stage 3 to stage 4. The other part for getting from stage 3 to stage 4 is like both the implementations. There need to be test to 62 tests defined, and implementations. Both the implementations that exist need to pass. That is when we say, hey, you actually conform to this. So that's already in place for anything that is beyond. Now, in terms of when we start looking at stuff that exists today, I think a great place to start is not only to look at what features V8 has, but what is the intersection of features that both V8 and Java has.
Yeah, the same rule, right?
Same rule. It's the intersection because I believe at least in terms of the long-term stable that exists, even the next version that's coming. I think everything that is supported by V8 is also supported by Java today. But I think if you look at the latest, that is future forward into a couple of extra areas, which are not big differentiators or like big differences. We can.
Oh, by the way, my laptop is empty, so. Oh, battery-wise?
But they are smallish. Intersection should be.
Oh yeah, I'm.
Best way to.
We could throw spots if you want. I'm still doing this release, so I prefer to.
262 right now.
I'm not.
Yes, sir.
Plugged in.
Like
They've started adding, yes, and that's why, because
give me like ES6. I want a strong baseline.
Let me start the thread with Brian.
Let's go ahead. Go ahead.
Okay, let's put it here.
That's awesome. Would Ian know how to run test? Do you know how to run test262 and pull up just the ES5 test or just the ES6 test or just the ES? I mean, either Brian or Gorkum should be able to help with that very quickly. Yeah, we can figure that out. Like both the editors for test262 sit in the same team room. Nice. So not a difficult job.
Awesome. Yeah, maybe that's something that we can put on the VM repo.
Not a difficult job. I think the bigger thing is to confirm whether it exists or not. I mean, whether that facility exists or not.
So, I think today we made a lot of progress in terms of just making sure that we're all on the same page at a high level. Tomorrow, we really do start breaking it down into concrete tasks. And the most immediate task that we've identified is, okay, yeah, there's all this stuff that we can do on VM neutrality, but before we can really make progress there, we have to find a way to shield the native module developers from that this VM stuff, right? And we talked about two specific approaches there. One being having an FFI storage within Node that the module use. And two, having a better API abstraction that these developers can use, so they're not having to include V8, right? So I think what we should probably do tomorrow is spend a good deal of at least the morning, if not the entire morning,
focusing specifically on that problem, right? And if we go in and think, if we're getting into it, we feel there's value in just putting doing that the whole day, then we can do that as well. But it is the more immediate problem. If we can also, as we go through the day, if we can, if we get to these other issues of, what are the tests that the node wants to say this is the minimum for node, or these other topics we talked about, then if we can get to those, then fantastic. But I really would like to get a better sense by the end of the day tomorrow. What are the very specific things that we need to do to make the lives of module developers easier, right? As far as attracting them away from the that's what I think is probably valuable. But that's just me. Anyone have any other ideas for tomorrow in terms of concrete things that need to be hammered out by the end of the day?
Concretely pushing forward on those two things, the FFI that we talked about and the API, do whatever discussion we can have on them and end up with as we go home and what are our next steps. And then on the other front, I guess I would suggest that, if we could even come up with, here's the list of all the problems we think we're going to have to overcome, but it's a bigger issue. We've talked about a whole bunch of things like, okay, well, how do you say it still knows when you have multiple VMs? But I think there's a lot of different aspects to that. We need to define actually what those different aspects were.
Not the list.
Yeah, just the list says like, well, we're going to have a compliance suite because we don't want somebody to write a module that runs on one or the other. What about subtle behavior differences? What about, well, do we want to have 20 binaries? Right? All the different sort of things we can come up with that we're going to run out. So just the list, I think, maybe it's a much bigger problem.
You're talking about the list of concern for VM neutrality?
Yeah. Yeah.
Yeah. So I think what would be okay, let's add to that one more thing. Really, like we discussed at the beginning of the day, like why do we want VM neutrality? And I think it'd be good to discuss it also in the Node TSC or the CSC, sorry. And so maybe to write a page or 3 slides where we emphasize it, so we can discuss it next week. Hopefully, not raise too many objections. There will be some concerns, but if we just say we're gonna do this without being explicit about our motivation, people are gonna ask what's your motivation? And that's a good question to ask if you have them. Right?
So document why.
Yep.
So I would suggest that we kind of break up in groups tomorrow, and because this is a very large group to design an abstract API with, and some people do that. Maybe some people work on an FFI sort of MVP proposal, and some people work on the documentation or and I find FFI very interesting. I don't have a lot of opinions about it, but I'd be fine working on either of the other 2 teams. So maybe it'd be an idea to to define our teams today and make sure everybody is comfortable. That's important. I remember the Air Summit where that kind of fell apart because I ended up in a group about a subject that I didn't care at all about.
No, plus I think we should also cross-pollinate. We start in the morning, we cross-pollinate in the afternoon before we break for lunch.
It shouldn't just, we should work and come back and try and bring the rest of the team up to that same level.
Yeah, so maybe at 1 p.m. we do everybody does a 10-minute presentation or just show it to people and then we can have a little bit more discussion.
So lunch is coming again tomorrow at 11. Start in the morning. Go ahead, split up.
Yeah, I would suggest that tomorrow morning we actually don't have a plenary session. We just figure out who's going to do what with whom, and then we can start as soon as people are here.
So let's figure out who those teams are before we leave here.
Yeah.
So we can get started as soon as possible. Let's do a. How many teams are we looking at? Maybe 3?
I think 3, right? That's sort of.
That's the 3 we just covered.
Well, I mean, you said actually we came with 4.
Yeah.
FFI, Abstract API,
what compliance means and motivation for VM abstraction. Right? So is that reasonable? Because we are like 4, 8.
I won't be here.
12, 16, 7. Okay, 16 people will be there. So that's four groups of 4 people. That seems good.
Okay. Well, then we go until maybe about 10:50. Give each group 10 minutes for lunch. Kind of, this is what we accomplished, or is that not enough time? We want to do that.
So let's assume like we start at like 8:45, practically speaking. So that means 2 hours. Maybe we could. I don't know. Like my feeling would be we should maybe do it after whatever. I don't really. I haven't so strong.
It gives a bit more time,
Or actually, it would be better if we did the presentations before lunch, because then during lunch, like
we can discuss it. Yeah, that's what I was thinking.
I'm not sure if all of them like the FFI and the module one, I think listing out the concerns and the reasons. I'm not sure that's going to be 2 hours.
That depends on who you end up in the group with. I can make that 2 hours.
To Bert's point, that facilitates CTC approval. So not just like throwing down the idea, but
gotta bike shed all.
Really get test it and pressure it, and come away with something that is meaningful to the CTC, not just like.
Okay, so let's do a quick poll. Who would be interested in working on FFI? I'm going to look at Ali and Alexis.
One of you guys should.
So I think so. Like that's good, because I see Google, I see Microsoft, and nobody from IBM so far.
I'd like to, but I'd really like to be involved in the API one.
Okay, the API abstraction. Who's going to be interested in that? Okay, you can only pick one. Okay, interest is okay, of course, but first preference for working on the API. 1, 2, 3, 4. Okay, I'm like if we do a group of 3 and 5, it seems not a big deal. Compliance. I'm looking at D. Shaw. James. That's only 2. And then the motivation, which, okay, I will take on. And you were already in another team.
I could miss you.
Okay, so we do the motivation. Is there anyone from Google who would like to join that? Maybe?
Yeah.
All right, cool. All right, does everybody know which group they're in now?
Yeah, and I can help you with the compliance as well. I think both of those would.
Is there anyone who does not have a group?
We have this room tonight. I will see if the other conferences, there's 2 other conferences if we need, I can say they're available tomorrow, and we'll see if I can go ahead and move those. Otherwise, we'll split this room up and have the 4th one.
Yeah, and also there's more inside, and I have a badge.
So we can split it up. So let's plan on when you get here in the morning, find your group. Go ahead and get started. We'll have coffee up here again. So before lunch, we'll get everyone together. Give each team 10 minutes. Get up, go through what they've covered, and then let's decide. Or we want to decide now what we're going to do in the afternoon, or wait till we get to those.
I think we should probably wait for presentations. It might be, I'm hopeful that, it could be, for example, that, we look at the motivation and like the other people that weren't on the team are like, well, this is a little bit flimsy. You have to go back to your drawing board. And it might also be that, everything is fine, and we just want to get a little bit more concrete on like what are the actions. Because I don't imagine that the people that are like going to investigate, the abstract API are actually going to implement it. So, it might be, you might need to do some schmoozing to get like Michael Dawson's team to do things, or,
So
that'd be the moment.
By the end of the day tomorrow, I want to make sure that we have concrete action steps. When we all leave, we know, okay, there are things that we need to do.
Yeah.
Or there are things we're expecting Michael to do. or what the
you know, it doesn't necessarily have to be in person, or whatever, but in a few weeks, in a month's time, if we come back together and say, okay, this is what we actually accomplished, right? Instead of just leaving it open-ended, like, okay, we'll do it eventually.
Yeah.
We actually, you know, time box. So if we can approach these different teams, not just discussing things in the abstract, but putting together a concrete proposal for this is what we think needs to be done. And if we're talking about it, we're going through the FFI stuff or whatever, and that crap, this may not actually work, this may not be the right thing, then okay, you know, let's discuss that and figure it out and do the different approaches.
But I mean, that's good because then the outcome can be like, we thought it through very well, but we decided that defining an abstract API was like a bad idea for some reason. We can at least decide to not think about it for the next 3 years, and that's also okay. Hopefully that won't happen, but
or it could be that, you know, this, if we went down this road, it's such a huge problem that it's going to take 3 years to get there, and we probably need to come up with something smaller. Right? Any other thoughts for things we should get done tomorrow?
Because you know, you called out sort of an action plan, volunteers probably part of it. Volunteering to get involved.
Right. So everything that we do decide. Now, ideally, I mean, this is done as transparently as possible. And if we, you know, you just spin up a team, or a work group within Node to say, okay, we're focusing on this problem. We need to make sure that we do have a follow-up and we know who's doing what, and that we have a venue for actually driving this forward. Having other people join in. Right.
Although I would say, like, I mean, there's a lot of good things to say about open governance, but I'm not, you know, the work groups are not necessarily very effective. So ideally, if it got concrete, we'd also be able to find some resources to actually get it done. Sure, IBM will be able to provide some.
Well, that's what I was saying. Some volunteers, like, we like to be able to say, like, on the HR side,
Yeah.
Hopefully, for the other ones, we can find people who commit some percentage. If we say, you know, a large part of the FFI stuff is probably going to have to be, you know, like there's probably something to do with, you know, yes, it's something that can either be done, you know, VM that like solutions. It'd be great if the VM teams were walking out of this and saying, we will have a pull request for Node within, you know, at some point it does the session or want to show down, right? It'd be great to have, you know, more direct involvement from the team in helping us PRs in Node and providing that support, if that's what we can. So, you know, having a clear sense of who's going to be doing that work, and then when are we going to follow up so that we can make sure that we're actually
what we do need work groups, like somewhere, like a repo somewhere where we can everybody can see it.
Well, I mean, I'm not saying it like I'm against a work group, but like just spinning up a work group and then hoping it will produce something good, that is not the way to go. Like, but if you can actually, like, if we say, well, we have half a person that can work on this, and they'll be part of the work group, and if more community members are, you know, willing to help out, that, you know, that's reasonable, I think.
So why wouldn't this be already on the existing API?
Well, isn't that focused on like the JavaScript side of the API?
It's
okay.
Technically, there's supposed to be two sides. One is the side, the native side also is supposed to work on the API working group. But yeah, like, both have been discussed. The issues. There's a section on how get the solution. Fortunately, on the native side, it got so drained. Yeah, it was an abstraction on an abstraction on an abstraction. I have no idea. Basically, everything in the end was avoided. So,
we don't, in terms of products, we don't need to go down the formal work like that. Our most active work group in Node is indeed even work group. It's just, you know, it's the LTS work group, but it's not actually chartered as a work group. So you don't actually have to have a formal process. You just have to have people willing to work on it.
Yeah, that is usually the much bigger issue. Yeah.
But somewhere that you can see what's happening, so it's not like 6 months from now we come back and say, here's something we did, right?
So the Error Summit is an example of this. So the Error Summit, you know, we talked about a lot of good things. Got some good documentation out of it, but so far I haven't seen any actual things from the Error Summit. I think, okay, it's probably valuable for making sure everybody's in the same way, but of what use and value was it? I would really like for for this to have some actual PR out of it.
Could be well, like just opening an EP and like come up with a minimal spec for the EP. People will get involved. Hopefully not to extend as much as it is, but
you just open a different repo for each like one.
Yeah, like come up with a basic implementation, write an EP for it, throw it up on the EP repo, and at least at that point, it's also easier to throw it to the CTC, so it can be like you can tell the CTC, hey, look, I think people are thinking about this. Can you look over it, give your comments? Yeah, it's a good way to help push things forward because there's something tangible in it. We can point people to.
Yeah, that might be a good first step. We have an idea for this is the concept. Throw it in there and start to see the discussion differently.
Okay, so we have 4 concrete work items for tomorrow. We have an idea of the themes. We have a plan. Again, by the end of the day tomorrow, it shouldn't just be, hey, you talked about it, great. Let's have, by the end of the day tomorrow, that these are concrete work items that we're going to keep with. Even if it's not what we originally started. But at least we have an idea that somebody's going to be doing something.
Right? So you want 2 EPs, one for the bottom, one for the tip. With what? Yeah.
And it doesn't even have to be something that ultimately 2 months from now we look at these EPs and say, oh, crap, yeah, that's not good. It's still beneficial. All right, thank you guys.
All right, awesome.
I wonder if we expected we could talk about that until something interesting.
Sure. Yeah. But that's, I think for some of that, let's try to at least sometime decide tomorrow afternoon for additional items.
Wow. The TC39 GitHub IOs, ES262, is already pointing to 17,000.
And which part to eat?
The UN emergency.
Here.
So we're there.
Yeah.
So Bert, did you look at the
So I'm not sure about that.
the what not the release. I mean, I looked at Mishko's proposal just before TC39, but not after. So it hasn't changed a lot.
No, it's I think they ended up doing a data container.
Man, this is a terrible time to go back.
But it's a much smaller version. I think it matches what we can like
yeah. Well, I mean, I think right now it's just passing.
Hey, yeah, take care. Yeah.
I mean, yes, and I think that's great actually, because I mean I had like an idea for zones with like the only Realcom now gives a name, of course, but the scope was much too broad, and TC39 sort of the same for Jack later?
Was that?
No, actually, it's already reduced. What?
If you guys are staying close by, you all can meet. I am. If I'm driving down to Sunnyvale, I'm not going to come back home.
Anyway,
So later does not work for me from that perspective. That came really handy, right? Yeah.
Yeah, I think. I mean, it's going to be a little bit of the question was like suppose against approve whatever it goes to the next stage. What the VM implementers will do and how much of it should go into Node. I think now it's all like wrapping, and, which is it works. Like we have this module called CLS, which has dependencies. But
I work with it.
yeah, and like it works. I mean, yeah, it works most of the time, and sometimes the behavior is a little surprising. But I think those issues will also just come up as people like start implementing it. And now there's a Fedora.
Ed is all fine.
People are actually.
Is he? Was he going to go?
No, to Texas.
Oh yes, you're absolutely right. He did tell me that.
Yeah, like, are you?
He told me he's going to be sitting there watching email.
So like the former strong team is mostly here, but we have like office days a week. But I'm like really not involved in doing anymore, so I go here like to socialize. And other than that, I mean, I don't have an assigned seat, for example, but everybody else has. But yeah, I do. So how do you feel about it?
I get worried when you have you have to be really careful that you what the language is. And if it's that, then it becomes I think maybe what
sure, you don't really care. Yeah.
They're not doing that scientific, but Node 4 I started because anything more than the language spec, one is not specified behavior. So we started to guarantee that the VMs can perform down. Right, so for example, I know there's an issue with properties. There's some edge cases which is not designed. So that VM can fix down the road and it's fine because you know this was really a bug you can fix it. But if it's not language specified behavior, then it's much harder to fix. How you would need it. So that's where I would. I'm hopeful that I can do something with FFI because most people who write models
so it sounds like at least in Node.
You don't actually want to write anything. So I don't want them to be like this. I think it's we can avoid having them like this, I think could be. But somebody will have to do the work. That's something I'm not clear on how much work on across the
Well, I think, yeah, I mean, hopefully, like I mean, it sounded like very negative. No, actually, I wasn't this. I mean, I think FFI in general is really cool and really good to have. Like, and that's sort of actually. Like from my perspective, especially now, it is. It's actually a little bit more than just C and C++. Like that's important for finding libraries, but like we have a ton of customers that want to use Node, but they have like Java stack.
That's another issue.
And they're like, well, that's so nice and dandy, but we need this like Oracle driver and so we need Java. Like how we're gonna So what people do is they, like similar to like how Node FFI is not very efficient. Like
Java is very efficient. It's like all kinds of, so like having facilities in the VM to like make reasonably fast calls out to like other languages, I think would be a boon for them. The risk I see is like it doesn't have too much value for the web, like because in the web you're not going to use it anyway. So I'm afraid that like from a priority perspective, like at Google and Microsoft, people are not going to care enough to actually like and we, there's Michael Dawson and SQL working on V8, but I'm not sure